we gather flesh. And
Alright,
bury it.
I won't let her be, so don't worry. Don't move, no,
Yeah,
it's easy.
nice.
Oh, no.
Going top. Yeah, he can stop. Oh, they reworked Hickory.
Alright, we've got it. Nice. Good job, dude.
They reworked him. What the hell? Does anyone know what he does? And good job, by the way. Oh, I'm coming. Well played. Nice one. Oh, this Graves is so dead. No, I'm dead. I'm dead. Graves is top. He's level 4. Graves top.
Looks used R.
Yeah, I'm out of mana for a while.
I have TP if you need it, bot.
I believe it's overpushed right now.
No, I mean later. If you need it, just tell me. Okay, good job. And coming mid. How is she faster than me? I can't swing her. Good job.
Yeah.
I'm coming.
Alright.
Just push the wave. Yeah, nice. Oh no. I couldn't sidestep.
Alright, good game.
Actually, it wasn't. It was easy. I guess we have to wait now.
Yeah, probably a few more minutes.
Be right back.
Alright.
It may be that for every star in the universe, there are billions of microscopic black holes streaming through the solar system, the planet, even our bodies every second. Sounds horrible. But hey, at least we'd have explained dark matter. 80% of the mass of our universe is completely invisible to us. Its existence is only revealed through its immense gravitational influence. This is dark matter, and it's one of the universe's most perplexing mysteries. These days, most dark matter hunters are trying to hypothesize or detect exotic new particles to explain the stuff, and we recently discussed some of the possibilities for brand new particle physics that might explain dark matter. Others are trying to find holes in Einstein's theory of gravity, the general theory of relativity, that might explain dark matter's influence without the need for actual matter. But there is one explanation that may require no new physics whatsoever, an explanation that is so bafflingly simple that it almost feels overlooked. What if dark matter is just black holes? These hyperdense holes in the fabric of spacetime seem to be great dark matter candidates, being so black and holy and all. As we've discussed many times before, black holes are regions of gravitational field so intense that not even light can escape. Evidence for the reality of black holes is now pretty convincing, and we've talked about this evidence before. The fact that we know black holes are actually real seems like a significant point in their favor. As an explanation for dark matter, it's more than we can say for any of the other dark matter particle candidates. So what would it take for this to be true? Well, dark matter makes up roughly 80% of the mass in the universe, but it's much more spread out than regular matter. For example, in our galaxy, it forms a vast halo around twice the diameter of the Milky Way spiral disk, where most of the stars are found. So, for black holes to be dark matter, they'd need to be abundant enough to make up all of this mass, and they'd need to be spread out in the same way that dark matter is. In other words, most of the physical universe needs to be vast swarms of black holes that outweigh all the atoms in the universe by a factor of 4. These are the non-negotiables for black holes as dark matter. The main remaining variable is the mass of the individual black holes. We could get to the required dark matter mass with lots of massive black holes, or with ludicrously many smaller black holes. We have of course been trying to find evidence for black hole dark matter for some time. Any given study is sensitive to a particular range of black hole masses. And if a study doesn't find enough black holes in that range, then that mass range is ruled out as a main contributor to dark matter. Scientific Method 101. Form a hypothesis, then try to prove it wrong. Our hypothesis is that dark matter is made of black holes. Today, we're going to go through the mass spectrum of black holes and close one window after another. We'll see at the end whether there are any gaps left, whether it's still possible for black holes to explain dark matter. But before we start eliminating specific black hole masses, let's rule out an entire class of black holes. In fact, we're going to rule out black holes from the only reliable astrophysical source, dead stars. We know black holes form from the only reliable masses. Let's rule out an entire class of black holes. In fact, we're going to rule out black holes from the only reliable astrophysical source, dead stars. We know black holes form from the remaining cores of the most massive stars after they explode as supernovae. We can make a pretty good estimate of the maximum possible number of these black holes by estimating the number of stars that formed and died through cosmic history. When we look into the distance, we're actually looking back in time, so we literally see star formation happening in the early universe. We can also see the products of these supernova explosions. Not so much the black holes, but the heavy elements forged in the cores of these stars during their death throes. That star formation history and heavy element abundance tells us that there haven't been anywhere near enough supernovae to give us enough black holes to make up all of dark matter. Also, if dark matter is produced as stars die,
Hey guys,
you'd expect its
you here?
influence to increase over time.
Yeah, I can.
We should ban like the champions from the PLAT guys.
Right, and can you hear me now?
Yeah.
Okay, perfect. So yeah, I would ban Kaisa maybe.
Maybe Samira because he has 80% win rate.
But only 3k a day with Samira, it's not so much.
Yeah, we should ban Kai'Sa. Maybe Jinx also.
I believe Samira can go mid, so eventually if the mid lane want to ban Samira, he can go for it. Like, Samira will counter Zilan, I believe. The same with
Yeah,
Veigar.
True. Samira counters him.
To give us enough black holes to make up all of dark matter. Also, if dark matter is produced as stars die, you'd expect its influence to increase over time. But we know that dark matter has been with us from the very beginning. The density fluctuations in the cosmic microwave background tell us that the gravity of dark matter was pulling matter together long before the first stars ever formed. So, if dark matter is made, we know that dark matter has been with us from the very beginning. The density fluctuations in the cosmic microwave background tell us that the gravity of dark matter was pulling matter together long before the first stars ever formed. So, if dark matter is made of black holes, then those black holes must have been with us from the beginning. Fortunately for our hypothesis, there is a reason to think that colossal numbers of supernovae to give us enough black holes to make up all of dark matter. Also, if dark matter is produced as stars die, you'd expect its influence to increase over time. But we know that dark matter has been
Yeah,
with
I
us from the very
agree.
beginning.
Rakan, Samira,
The
Kai'Sa.
density fluctuations in the cosmic microwave background tell us that the gravity of dark matter was pulling matter together long before the first stars ever formed. So, if dark matter is made of black holes, then those black holes must have been with us from the beginning. Fortunately for our hypothesis, there is a reason to think that colossal numbers of black holes may have formed in the very early universe. We call these primordial black holes. Now, we've talked about these before,
No, our
but
jungler
let's dig much
plays.
deeper.
Just pick for him. Pick him Viega.
Yeah, we are first pick, so it's much better for
Yeah,
us.
we're first pick. Yeah, you can pick E, just ban the two AD carries, please.
They is banned already.
Yeah, I know, that's why you banned her first. Next you can ban Jinx.
Not
No,
the
sorry,
Jinx, rather
Samira,
Samira.
Samira,
Yeah.
sorry. Yeah, I misspoke. Oh, they banned my Trinda. Okay. Oh, and they banned Singed. Okay.
Pick Vigo. Nice, we've got it.
They banned the. Do you see? You have to pick Zilan. Oh. Also, Smith, they banned 2 of my mains, so if you could pick Heimerdinger for me, that would be great. So I suppose you want the Thresh, right?
Oh, there's a new champion here? Okay, I need to check the Gwen on the YouTube then.
Yeah, I have no idea what it does. I know it's AP Bruiser, and it's kinda strong.
Let's see. Oh, she's top lane, yeah, so we need to check her.
Oh, they banned Thresh again. So you want Blitz? Yeah, okay. Yeah, so it's not useless, like, what the hell?
Right, be right back.
Okay.
Right, I believe we can invade again.
Let's go. I am very strong in level 1 fight.
Right, close though.
Flash for flash, okay.
And we can re-invade again. I believe we can go again.
Yeah, let's go here.
I'm pretty sure it's guarded, but anyway. Just start with ward. Start with ward.
Okay, I'm going top.
Alright, yeah, it's a good time to go top right now.
Oh, he started top.
Yeah.
Oh, I got half her HP.
Oops.
Kha'Zix is going bottom.
Right, the bottom is following up, both of them.
Yeah.
So I'm not able to follow them because the Lona will kill me then.
Careful, Kha'Zix has 3 kills. I
He
think they wanna do
choose-
Drake. I'm saving my TP for a play bot. Well played, guys.
Drop, good drop. Can we Drake right now?
Yeah, I think you can.
Yeah, nice.
Yeah, Kha'Zix is stop. Go for it.
Yeah, nice. I've got a heal right now, so it's perfect.
I'm coming. Oh, you got one shot. Sorry for that.
Nice. Nice, just kill that fire.
Oh no. I fucked up.
I've got the ultimate. Ooh. Close.
Kha'Zix bottom.
I think they might be coming. Wait for my trap, wait for my trap. Okay, okay.
Just back off. They're 4 mid.
We can go for Kha'Zix. Nice.
She trolled him. Nice, nice.
I believe
Just
we
have
it.
to.
Okay, now Azir now. We can take him as well. Oh. I believe he's going back from that side somewhere there. Can you take Herald, Vigo? I believe we can take the tower.
Yeah, we can take it. We can take it for sure.
Let's kill him.
He pulled him. Yeah, good job.
Oh no, run. Whew, close.
Oh, he survived.
Oh, run! Ah, damn it. Little lucky though. Nice, good job. Perfect. I've got an ultimate, I've got everything right now. Oh,
Drake up soon.
yeah. We can do Drake right now, I believe. Oh, that's... Oops, done with iron. Fuck. Perfect, not so perfect. Yeah.
Okay, I got first blood. Jinx used R. Kha'Zix is top. I have TP again. If they gank about that, will TP.
Right, I believe that it's better to go back right now, because they will be coming. Alright, can you pull her? Pull her here?
Coming. TPing in. Help me. Oh,
Well, I cannot do much more.
Kha'Zix is so fed.
Yeah.
Jinx is one shot though. Well played.
Yep.
Well played. We got them all. Yeah.
I...
was worth.
Alright, so now the game can be really nice.
Yeah.
We take the soul, it will be over.
It's over right now, you got 6 kills. If Blitz can protect you from Kha'Zix, it's GG.
Alright, and now the tower is down. Perfect. Right, I will be coming.
Oh, they're here, okay.
Oh,
Oh, he nearly died.
Yeah, this one more tower.
Oh my god. How is this
Right,
champion
I'm
so
coming there though.
strong? Azir used R. You got him, you got him.
Oh, what the hell? She W dodged my skills. It's strange. It's very strange. The next Drake, we're supposed to focus on Drake right now. Let's
Yeah,
give it away here. Just push mid lane because the bot is pushing itself.
I'm coming to Drake.
So we need to fast push in here, and then we'll be perfect. I already set it up for it, so yeah. Let's take the small.
Trap them here. Trap
Yeah.
them.
Oh.
Okay.
Let's take it. Let's take this one.
We should back off.
Okay, let's focus Kha'Zix first.
I did a lot of damage there. I think we good.
Okay, yeah, we are quite good.
Oh, nice.
Oh, I missed. Whoa, no. So
It's
many
okay, take
misses.
the Drake. Nice, nice. And Blitz survived. Well played.
Ooh, this Kha'Zix damn almost killed me.
Yeah. We could also take Herald if some of you come to help.
Oh yeah, I believe you can take it by yourself. It's not a big deal actually.
Yeah, true, but I only have like 40 seconds.
Oh, okay, so yes, someone will be nice.
Because of the time, I'm saying. I need more damage.
Okay, so, oh. This Kha'Zix is tough.
Kha'Zix on the red. He's recalling. Can you get mid turret? It's really low.
Or we can protect the bot lane as well. It's hard to say what's better. We just need one more Drake for victory, so yeah. This game is going pretty nice.
I'm dropping Herald mid, but I think we should get this before I drop it. Because it's not worth to use
Yeah,
it.
it would be nice to get it before and like push the second tower. But how long is the herald? Can you wait for like the
I have
Drake
it
time?
like, yeah, 3 minutes.
Right.
Okay, she flashed.
Ah, yeah. But Azir's dead.
Okay. I'm dropping Hero. We should get in here, I think.
Nice.
Push mid, guys.
Whoa, nice. We got inhibitor right now. It's
Yeah.
or can we rush Baron maybe?
I think we can trap here. Make
Or
them
just-
think we went Baron.
Yeah, but I don't think they will fall. We need to protect as well.
Yeah, you guys go Baron.
Oh yeah, or
I'm
wait for
gonna
Kha'Zix.
trap
Well, wait
them.
for Kha'Zix. Kha'Zix is stupid
Yeah,
enough
yeah.
to come. That's interesting.
Nice, go for it.
Now we can go Baron. Yeah.
Yeah, I told you this was the play.
Yeah. Alright, so yeah, it's nice then, I believe. Nice.
They can't even contest this.
And you can try to keep away like the Azir.
Yeah,
if he
that's what
goes
I'm-
away.
But nobody's
Maybe
coming
not.
so far. So yeah, I think we good. Now go back and top
Perfect.
lane. We should also get the top inhib. Oh, the Drake's coming up, never mind.
Yeah, the soul.
We need to go bot side. Kha'Zix stops it.
If we take down the parts, really nice. Ooh, look at him. Damn, Leon protected.
No problem. I think we still get Drake actually.
Yeah, I believe we can wait for a couple more seconds.
Do you have a pink ward, Blitz? Oh, I missed. Sorry. Oh, oh wow. I do a lot of damage to him. Nice. Give me blue, please.
Alright, yeah, sure.
Thanks.
Start the Drake.
I think you should last hit the Drake.
Yeah, the fourth hit, yeah.
It does more than smite actually.
Yeah, it does a lot with more than smite. Okay, maybe.
Okay. Oh wow, it does like 1,000.
It's like the 25 missing half, so yeah,
Yeah.
it's quite powerful.
He already has a lot of HD and crit, and then it does like execute damage.
I don't know if I can get her or not. Where is she? Oh, no. Probably she's going back from that side. Not?
Did you stop her?
Oh yeah, she went there.
Oh.
Okay.
Yeah,
Still.
just pushed up. We have to use the Baron buff.
Ooh, flashed.
Oh wow, that did 0 damage to me. because of the soul. Ah. Oh, I
Oops.
went for the bait and it didn't work. Oh, oh, wow.
Oh,
Okay.
oops, no, nope, nope, nope. Yeah.
Didn't see the Kazakhs there. Yeah, we greeted.
Oops. Okay. Right, I'm ignited, that's okay.
Oh, well played, guys. I'm TPing bot.
OG. It's time.
Help me bot, help me bot. I
Right,
think
now
we should
take
back.
the top.
Yeah, maybe take top, but we should back then. No, no, back, back. Oh, you have. to
I think you can
back.
end it right
Oh,
now.
what the hell? I
Oh,
didn't know
lucky.
you were that fat.
Why is she immune? It's strange.
When she's in the circle, you can't hurt her. You have to step inside the circle.
Oh, okay.
Yeah, yeah, it's super OP. Yeah, it's like Zin, exactly.
I hit him or not?
Okay,
think-
get him, get him.
No, I was just quite out of my range. Oh, okay, so we can take it
Oh,
down.
she missed me. Okay.
Oof. Right, oh yeah, we can go back right now. I got like 5k, so yeah.
Yeah, we can Baron and actually maybe I can solo Baron.
Okay, I'm full build right now, it's perfect.
Yeah, we got duo Baron. Easy.
It's all about the damage with the Jean.
Yeah.
It's like super huge.
Also the move speed.
Oh,
That's why you get Swifties.
oh, it's unlucky. So, oh, I missed. Nice. Yeah, well played.
We were actually losing early game.
Yeah, that's a little.
Yeah, but it was just Kha'Zix.
Okay, so who will be playing? Oh, they haven't finished yet. It's 31 minutes.
They haven't.
So, yeah, it's be right back then.
Yeah, just always play for objectives, not kills.
Unmuted. Yes. Can you hear me? Hear me? Uh, uh, uh,
Guys, we should ban Kaisa again. Also Gragas, Morgana.
Or maybe, yeah, Kaisa for sure.
Morgana, look.
But he's going to play Eddie Carey. So it's not a big deal.
I don't think so. I think the guy on the right, the gold guy, will play AD carry.
I would prefer. Yeah, if the gold guy is going to play AD carry, it won't be a big deal then. But I see the history and mostly the. Oh, let's take a look at it. It's interesting. You probably Gragas? Yeah. Can you check their games history? Who they were playing before? Like in the tournament or something?
I'm not sure. Wait, let me see.
Other.
Yeah. Okay, so the gold guy played support, Morgana and Leona. Also they have Ornn and Yasuo. So the top guy is playing tanks mostly, I think.
Well, that should be Gucci then. We can also go ban like Samira because she can be tough later. Or Hekarim. Hekarim might be a problem. It's hard to say.
Yeah, you're right. Hikarim. I would ban Kai'Sa, to be honest.
Yeah, Kai'Sa and Hekarim seems legit, and then we'll see.
Stanimir, you here? We start in 30 seconds. Got more sauces for pizza. Good for you.
Can one of you confirm that you hear me?
Sorry, what did you say?
Can you hear me?
Yeah, we
Oh
can
yeah, we
hear you.
can.
I had to mute myself last two games. My parents watch TV very loud.
Oh, okay.
Alright.
I know it sounds like shit on the other side.
Everyone is banning Yi, I'm surprised.
Yeah, they're so scared of him.
We have like 2 million points combined on you.
Yeah. It's okay, Stanimir. They ban your Yi, we fuck them up.
Alright, Kai'Sa ban? Alright, went nice. I'm afraid they might go ban like Jhin this time, but I'm not sure.
Yeah, maybe Stanimir should pick Viego again.
Yeah, definitely he should be picking, but they are
Yeah,
having the first
because-
pick. Oh, they banned the Viego.
Oh,
Well, there's no need to ban Wayne, definitely, but more likely Samira maybe?
yeah, Samira
Or Hekarim.
Hikarim.
Hekarim seems to be a
yeah.
problem. I mean, but Hecarim has like an ultimate on bot lane, so he might be making like a
Yeah, but
gank.
before when I was playing versus Hecarim, they changed him. He's reworked. And he kinda sucks, to be honest.
So how does Hecarim was changed?
I don't know, it looked like Fiddle, you know, when he drains you.
Yeah.
It was so weird. His ultimate did like... It had a lesser area.
Need to check it.
Oh,
Oh yeah, nice. Oh, and the trash is open.
yeah, they will ban Singed or Thresh. But Thresh is bad versus Morgana, I think.
Yeah, and against Israel as well.
Smith, can you pick Singed?
Yeah. Oh, single
Because
Wenger.
they will ban it probably.
Oh, you got both pick actually. Oh, Seager. Oh, it's so no trash then. Yeah, they got like a double shield. I don't know what kind of support can you take, like
It's
Lulu or
okay,
maybe Yumi.
I can play versus Ornn, no problem.
I don't know what kind of support can he take. They have built like double shield, so probably won't get any CC.
Yeah, just something safe, like, I don't know what he plays, but maybe Soraka or something like
Or
that.
Yumi.
I don't...
What
Yumi,
can I
yeah,
think about
that
that?
would be good. He can hear us,
Right, yeah.
so you can just talk, I think.
I'm thinking of any others as well.
No, come on. Why are they so scared?
Or maybe wait, let's see. Or Brown is pretty safe as well. Or no, not Brown.
Yeah,
No,
Lulu
Morgana
also.
will be tough then.
Lulu or Jaina. Yeah, Jaina.
Janna.
Should work, yeah.
No, I see. Janna will be perfect actually.
Should I pick a tank? But I only play Singed tank.
Oh, Veigar's actually Hammer seems pretty well.
Yeah, it's okay, but we have no front line. That's what worries me.
I don't, I'm not sure there would be an issue with like Veigar. And we've got Janna as well, so yes, so Janna will just pull them away.
True, true.
Oh, they've got like Mumu. They're going pretty up AP already. Like lots of magic damage.
Yeah, they have a great CC team. A lot of CC.
Yeah, but lots of like AP damage. We'll see if they take the 4th AP or AD. Otherwise we can go like magic resist. Actually, at least, oh, no one can go magic resist.
I will be going anti-tank items this game. For sure.
I got like Sudden. Yeah, Janna would be perfect actually.
Yeah, yeah. Also get magic resist this
Get rid of that Mumu or Kassadin or just pull them away. And I believe Janna can go like Ignite this time. Through of the Exhaust because... Well, I'm not sure that it's Exhaust or Ignite against them because the Morgana has a shield, so probably sometimes Exhaust is worthless. So maybe even Ignite would be better. Yeah,
Yeah, true.
perfect.
Or maybe Jaina heal and you take barrier or cleanse. I don't know what you like.
No, it's okay. It's pretty good with the heal. And Ignite is quite needed actually.
I think I'll just go Leandris and be a poke machine.
I need to check something though.
Oh, this loaded quick. I like it.
Alright, so let's invade for sure.
Yeah, let's go.
We got the better
Although they
chance.
have a Mumu Morgana.
Oh, it doesn't matter actually, we can burst them. And Veigar, take the damage, don't take the stun, just take the damage. Let's go all together. Oh, Rengar, come
Yeah,
on, let's invade
Take
all
the,
together, we
take
can
the
burst
stun,
them.
Veigar.
We've
Take
got
the
an
W.
ignite, we've got so much damage. I've got the fourth shot, so it's perfect. We just need to burst them, all damage. All we take is damage.
No, don't go Leandris,
Oh,
I
damn
go
it.
Leandris. Stanimir, do you hear me? Don't go Leandris, I will buy. I'll go Leandris, it doesn't stack, so you should go for Ludens. Yes, but yeah, exactly, you need burst. You need to nuke them, Harvester or Ludens.
Right,
Oh,
Janna, we can hard push the first lane, just keep... Oh, no. Run. Right, perfect. Okay, I didn't suppose that to
Casting
happen.
has no ward. This is the first game we're on the top right side, I think.
Yeah. Oh, she did hit me. Damn it. Nice. Some damage to her. Oh, I missed the big one. Damn it.
Momo is mid. I actually used TP so they couldn't chase him down. Just push it in back, Veigar. Back, Veigar, back. You have no mana. Maybe you can gank mid, actually, Rengar. Momo is bot.
Yeah.
Sivir has no flash.
Oh, I kill it? Yes. Nice.
Well played.
Run. Oof.
They were too greedy, right?
Yeah, they were quite greedy. But I'm gonna start shoes though. Or not shoes. Get just enough cash for it. And potions, then yeah. Take some damage. Oh, but she will be ahead with the farm right now. Rengar, be careful on the bot lane because of the Morganite, may be tough. Oh, another big loss.
Znowu są samo oglądać, no to tylko nie widzę.
I hear some background sound.
A, tak.
Yeah.
Oh, a Momo's top side. Yeah. He stopped.
John, she's in Morgana's in the bush, or not? Okay, nice. Ooh.
A Momo's doing the top side crab.
Can we Drake maybe? If Amumu stop?
Yeah, go Drake. He's
Would be
level
perfect.
4.
We can push this lane as well. We can push it fast. And then we are free to Drake. Okay, let's Drake. Go back and Drake. Let's just go Drake there.
Momo's on Raptors.
Perfect.
Good job.
Oh, Amumu's coming, so let's go back.
He's going bot or top? Oh,
Amumu's bot lane. Go back, Jenna, go back. It's not worth to go so deep.
Oh, he trolled hard.
Alright, I believe you may go back, Jenna, because if she will get ultimate, you may be quite lost actually.
Oh, you have such good vision on bot side, I like that.
Yeah, just for the Mumus.
Yeah, he's one level behind because he's ganking all the time.
Right, I will go back right now. I've got enough cash, so it's okay. Or maybe not, just one more lane.
I think Momo's here, not sure though.
Right, can you come bot lane, Janna? Because it's good time to kill, I believe. I'll go back, it will be easy. Oh,
Oh, I'm almost here. Yeah, I got the Amumu. He also flashed.
nice. Okay, I believe you can take the plate because as long as they're away.
This Kassadin should be dead, I think.
So if we push us, it'll be perfect.
Nice. Very nice. Oh, he got executed. Nice.
Well, this game goes very well.
Yep. Amumu's topside again. I saw him. Also, Amumu flashed.
Oh, he's on 6 right now though.
Also, he used his R just now, so you're
Damn, I
safe.
didn't pick a ward, I had no place for ward. Took some damage to me.
Oh, I just inted. My bad.
Right, I'm coming there.
Should I TP?
In a moment, probably. Yeah. Ooh, oh, so far? What the fuck?
Okay, coming. Kassadin on me, help me.
Right, I don't have a heal right now.
Well played.
Well played, very well played. Nice, we've got everything.
Yeah.
Alright, and we can push right now. It's perfect. Right, I need like 200 more, so the plate will be perfect gold. Alright, one more lane and we can go back.
Amumu bot.
Alright, yeah, I just go flash because otherwise he would kill me.
Yeah.
I believe he's in the bush, so yeah. Right, I've got enough cash, let's go back because the demo must be camping somewhere in here.
Momo on Raptors.
Right, Amon is going bot lane.
Yeah, yeah.
Careful Janna because he was somewhere there.
A Momo on blue.
Alright, Cassandra was somewhere in here. Let's see. Oh, no.
I'm getting first blood though. I'm coming mid.
Alright, can you make it?
Okay, go, go, go!
Alright, the Drake will be right now, damn it. Overstayed a second.
Orange here. Oh, Veigar, go back. Oh wow, she insta died. We got Drake. Drake.
We're supposed to take it. Right, I've got the pink fort. One goes away. Oh,
How does he steal that?
I don't know.
He's level 9.
It's not enough, not a big deal though.
No, it's not. It's not.
I believe we can go for Herald right now.
Yeah, yeah.
Let's see it here.
I'm coming. I'm gonna TP bot actually to death. Yeah.
Like, oh,
I think this should be GG.
I believe we can like push mid lane right now a little. There are 3 are missing, so please be careful any pushing lanes.
A moment mid.
Alright, I will go Herald. This tower is full, maybe we can take another one as well.
It's Baron actually. Oh, you mean you'll drop it? I get
Yeah.
it.
We can take another tower as well. Oh, damn it. Lucky. There's Drake in like a minute or so.
Yeah.
So we can do shopping right now and go all Drake. Alright, Amumi used his smite.
Yeah, he has 2 smites. I'm pushing bot. Oh, Ranger's so fat.
Alright, so let's go fast push mid, mid. So they cut Drake for a tower. I don't know if you can steal it, but I will just go full
Oh,
mid,
I
so
nearly got it actually. It was on 60 HP.
I'm gonna fast push mid. Just don't let them back. Just don't let them back.
Oh, sorry, I had to back myself.
But just don't let them. It will be nice.
They're back.
Alright, so I'll go back in a second.
I have TP actually in 2 seconds.
Nice, I've got the tower, it's okay.
Okay, we should top now. Or Baron. Actually, Baron. Jin, if you come with me, I think we can. do
It's.
a-
I'm afraid it's far. That we don't have a position for a Baron right now.
I think we do because they're all bot.
All right, we can try it though.
I'm getting.
Oh,
my
they
army in
Varded.
3
Go back, go
seconds.
back, go back. It's worth it, worth it.
Yeah, I'm going back. I can't stop my turrets though.
Alright,
So
then we can continue.
still do it, I think. Not sure. I can't tank it though. Oh, I got the Sivir.
Worth it, nice.
Yeah. I gladly die for 3 kills.
Oh. Sure.
Rip.
He don't have any more movement speed to continue. He's around.
You can Baron. Easy Baron.
Yeah, they can do it without me, so it's okay. Right. Perfect. Stuff. Alright, let's just go back, save Baron, it's okay, we can defense right now.
Oh, Ranger's dead.
Yeah. I've got an ultimate in a second, so actually we can
Yeah,
keep
go
them
for it.
for a moment. He's stupid or what?
Yeah, I think so.
Oh, I missed. Can I have this blue? I'm like
Yeah,
out of mana quickly.
Go for it.
Alright, it's time to buy, I believe. I believe we should push one of the lanes, maybe bot lane.
Yeah.
We're close over there. And ready for Drake. Okay, perfect.
Castle in here.
Alright, maybe we can even end this right now.
Maybe, yeah.
Ooh, nice.
Oh my god, I missed, sorry.
Yeah, I missed too. More than once.
I didn't have vision for a moment there. Actually, yeah, I'm just going mid.
Good job, dudes. I think we've got it.
this game was actually easier than the last.
Yeah. It's 12:33.
GG.
It's GG.
Is this the last game?
Yeah, I think we have won.
So what do we get now? It's my first time playing Clash.
I'm not sure actually. Bracket 1. Oh, nice Clash winner.
Into the question of whether primordial black holes could explain dark matter. There are a few ways that primordial black holes could form, but the most mainstream mechanism is that they collapsed from density fluctuations. We know there were the question of whether primordial black holes form, but the most mainstream mechanism is that they collapsed from density fluctuations. We know there were regions in the early universe that had a bit more matter than other regions. We see that in the cosmic microwave background from around 300,000 years after the Big Bang. Those fluctuations would have been much stronger at earlier times, and perhaps strong enough that the most massive of them would have collapsed into black holes. Now, those black holes should have all formed at around the same mass, and perhaps those fluctuations in the microwave background from around 300 more matter than other regions. We know there were regions in the early universe that had a bit more matter years after the Big Bang, and perhaps now strong enough that the most massive of them would have collapsed into black holes. Now, those black holes should have all formed at around the same mass, but that mass depends on the details of the state of the early universe and could be anything from a grain of salt to tens of thousands of suns. Because of this, to really falsify the primordial black hole as dark matter hypothesis, we need to rule out this entire mass range. Okay, let's get started. We'll begin with the extreme ends of the mass spectrum. Those are easy. The most massive black holes in the universe weigh in at millions to billions of times the mass of our sun. We see these supermassive black holes in the centers of essentially all galaxies. Dark matter can't be made of these or anything close to, because these black holes tend to fall to the centers of their galaxies pretty quickly. At the opposite end of the mass spectrum, we have black holes under 1 billion tons, or around the mass of a small mountain. We can rule these out because by now all of these would have evaporated as Hawking radiation. Now, there's a terrifying caveat here that I'll save for the very end. We can also rule out black holes a bit larger than this as dark matter. For dark matter to be made of black holes with masses around that of a larger asteroid or a small moon, we'd need truly ridiculous numbers of them to get all of the dark matter we need. I'm talking somewhere between a billion to a billion times more of them than there are stars in the universe. Even though these black holes would have microscopic event horizons, at those insane abundances, they'd be wreaking absolute havoc in various astrophysical objects. For example, they'd puncture white dwarfs and neutron stars on a regular basis. A primordial micro black hole would pass right through a white dwarf, but it would deposit enough heat to allow the star's ultra-dense carbon and oxygen to undergo nuclear fusion. Like striking a match, this would ignite a cataclysmic chain reaction, exploding the star as a Type 1a supernova. Neutron stars are a bit different. They're so dense that they would stop a microscopic black hole in its tracks. The black hole would then swallow the neutron star from the inside out. But we see too few Type 1a supernovae and too many neutron stars for this to be a common phenomenon. Probably no more than a few % of the dark matter mass can be from these micro black holes. Okay, let's move up the black hole mass spectrum to masses around that of a planet. At this point, gravitational lensing becomes the go-to method for dark matter hunters. When a compact mass, like a black hole, passes in front of a distant light source, the warped spacetime around the black hole acts like a lens, magnifying the source in an effect called microlensing. Microlensing doesn't necessarily tell you whether the lensing object is a black hole or some other dark compact mass like a brown dwarf star, a neutron star, a Dyson sphere, or a cluster of Reaper capital ships. As long as they're massive, compact, and dwell in vast numbers throughout the halo of the Milky Way, watching and waiting. Broadly, we call this breed of dark matter candidate machos, massive compact halo objects. The best way to search for machos in our galaxy is to monitor the stars in the galactic bulge or in our neighbouring galaxies to see if they fluctuate in brightness due to microlensing. A dedicated telescope on Mount Stromlo in Australia pioneered this work throughout the 90s. The very first macho microlensing events were detected, but there weren't nearly enough to account for dark matter. Since then, further surveys have really nailed down the constraints. The Magellanic Clouds are especially good for this. The low level of microlensing of stars in these mini galaxies has allowed us to rule out machos between roughly the Moon's mass to 10 or so times the mass of the Sun as a main contributor to dark matter. But even if machos aren't all of dark matter, studies of the Magellanic Clouds and Andromeda have found enough microlensing events to suggest that 20% of the mass of the Milky Way halo may be dark compact objects with the masses of a small star, and we can't rule out these as primordial black holes, nor as reapers, but there's no good evidence of either. So far, we've mostly ruled out black holes around the Sun's mass or lower as an explanation for dark matter. Larger black holes are tricky, because you need fewer of them to make up the mass of dark matter, which means they're less likely to be spotted through microlensing studies. As dark matter, larger black holes are tricky, because you need fewer of them to make up the mass of dark matter, which means they're less likely to be spotted through microlensing studies. Larger black holes are tricky, because you need fewer of them to make up the mass of dark matter, which means they're less likely to be spotted through microlensing studies. As I mentioned, the most massive black holes trickle to the centre of our galaxy, but there's an intermediate mass range from tens to thousands of solar masses that could still be abundant throughout the Milky Way. One way to test that is to look at dwarf galaxies. These galaxies are so small and dense that even black holes with tens of solar masses should have trickled to the centre by now, and in the process flung less massive stars into higher orbits. Studies of the structures of dwarf galaxies tell us that no more than 4% of the dark matter could be black holes of tens to thousands of solar masses. The existence of loosely bound binary star systems throughout our galaxy gives us similar constraints. If there were lots of black holes of several tens times the Sun's mass, then these binaries would long ago have been torn apart by close encounters. Okay, so there we have it. We have some evidence ruling out most of the black hole mass spectrum as the main source of dark matter. There are a few narrow windows remaining, but these are just the windows where our studies are less sensitive. And frankly, it's unlikely that it just so happens that all of dark matter is packed into the spots we haven't properly looked at yet. So dark matter probably isn't black holes. But don't be sad. That means dark matter is probably something that physics hasn't explained yet. which means when we figure it out, we'll have a window into new physics. And who knows what we'll find there? But speaking of new physics, one last option. It's speculated that an evaporated black hole might leave behind a tiny, naked singularity, a speck of infinite density weighing less than a grain of salt. These so-called Planck relics are bad news as dark matter because they're essentially undetectable, and also because there would have to be at least a few in the room with you right now. Whatever the case, dark matter is freaky stuff, fitting as the main material ingredient of our generally freaky space-time.
They say the
Hello wonderful person, this is Anton, and well, generally it's actually really difficult for me to sometimes find the right words to use when I'm discussing some sort of a tragic event. In this case, it's the event that a lot of you are probably already familiar with based on a lot of media reports from August of last year. The absolutely insane explosion that happened in the port of Beirut that essentially created one of the largest non-nuclear explosions to ever occur on the planet. And in the last few months, several scientists wanted to investigate this particular explosion from a scientific perspective, and specifically looking at various effects that this explosion produced in the atmosphere. Now, a lot of these videos were shared by this wonderful person, this wonderful international correspondent, Borov6, who published all of these videos on his Twitter, and you can actually find all of them in the description below. But for this video, I really wanted to focus on some of the facts we've discovered over the past few months, and also just generally talk about what this explosion created in terms of the atmospheric effects. Now, first of all, as you might already know, this is not the most powerful explosion to occur. That record goes to the infamous Tsar bomb that was exploded by the Soviet Union. And in terms of the most powerful non-nuclear explosions, the record for that goes to the Halifax explosion that occurred in 1917 in the city of Halifax in Canada, when a boat carrying various ammunitions from World War I ended up destroying most of the city of Halifax, creating a tremendous amount of damage in the process. But according to at least one study from last year, the explosion that happened in Beirut was about half as strong, yet produced a lot of effects that were not observed in some of the other explosions. In other words, despite its lower yield, it actually seemed to have been more powerful overall, and also ended up producing a humongous crater that you can kind of see in this image from Google Maps. But before we talk about the details of some of these studies, what exactly happened here and what exactly exploded? Because obviously that's really where the story should start. Well, it turns out this is a very tragic story of a lot of incompetence and a lot of mismanagement, which essentially led to tragic loss of life. The story starts right here with this ship known as Borov6, which originally sailed from the city in Georgia, the country, not the state, trying to transport approximately 3 tons of ammonia to the African country of Mozambique. And according to some of the reporters, the shipment itself was meant for a mining company operating in Mozambique who were trying to create a lot of explosions for the mining operations in Mozambique, with the ammonium nitrate itself coming from this facility in Georgia known as Rustavi Azot, with this particular facility most likely being the cheaper choice as opposed to some of the other facilities around the world. But apparently the Panama company that was operated by a Russian who allegedly owned the ship did not have enough money for the ship to pass through the Suez Canal. And so in order to make some money, they tried to take on extra shipment in the port of Beirut to essentially allow for the cheaper passage. But because the new shipment was essentially heavy machinery and the ship was already overloaded with ammonium nitrate, a major part of the ship ended up being damaged and was deemed unseaworthy by the authorities in the port of Beirut, which forced the ship to be stranded right here in Beirut for a very long time. And because the owner did not have enough money to repair the ship, nor did he have any money to pay for anything at this point, the crew of the ship ended up being stranded there for at least a year. And by the way, all of this was back in 2013, but by 2014 the ship was officially seized by the authorities because none of the bills were paid and nothing was done to repair the ship. And also on top of this, because the original company that ordered the product no longer was interested in it. And so the Russian owner of the ship decided to just abandon it along with the crew. But unfortunately, due to a lot of internal bureaucracy, and I guess in some sense due to the lack of regulations on what to do in this case, a lot of the cargo from the ship ended up being stored inside the port itself, while the ship itself simply was left to rot in the harbor, eventually sinking within about 4 years. By 2018, it was basically on the bottom of the ocean. And what happens after this? Well, I guess we know the story. The cargo was just stored there because nobody really wanted it, and the authorities could not figure out what to do with it or how to get rid of it. Mostly due to the internal bureaucracy, but also just because, well, that's just such an unusual case. And unfortunately, for some reason or another, at some point there was a fire in the warehouse, and well, you know the rest. But along with the ammonium nitrate, the warehouse also had a bunch of fireworks, which you can actually even see exploding prior to the major explosion, and all of this most likely led to the spread of the fire and then eventually the explosion. But the telltale sign of what exactly exploded was actually the cloud itself. It was the color of the cloud. The reddish cloud that you see, that's formed by the nitrogen dioxide. And nitrogen dioxide is a byproduct of a burning reaction of nitrates. And so when nitrates decompose, they usually produce this type of a color. And now a lot of new studies also established the total approximate power of this explosion, and they also were able to calculate various other effects, including the effects on the ionosphere, which was mostly caused by this huge pressure wave you can see moving away from the center of the explosion. And strangely enough, the explosion was so powerful that it led to various disturbances of electrons located really high up in the Earth's atmosphere. Ionosphere being that upper layer of the Earth's atmosphere where a lot of electromagnetic effects are usually found, including things like, for example, northern lights. And so this explosion produced something that's about 1.12 kiloton of power, which is about 1/20th of the Hiroshima bomb, and the explosion then produced a really powerful shockwave that traveled southwards at a speed of about 0.8 kilometers per second, or about 1600 feet per second, with the wave then creating a kind of a bulge right here above the explosion. But what's interesting here is how all of this was discovered. The scientists whose study you can find in the description below were able to analyze all of this using data from various GPS satellites, or basically by looking at the slight delays that the microwave signals from the GPS were experiencing compared to some of the other ground stations in the area. They were able to calculate the exact electron density present in certain parts of the ionosphere before, during, and after the explosion. And the presence of electrons in the ionosphere generally affects the GPS signal and usually has to be calculated extremely precisely. And so the changes in the density of electrons above the explosion became apparent almost instantly. Mostly because a lot of the GPS in the area directly depends on a lot of these calculations in order to function properly. And these calculations also allowed the scientists to more precisely estimate how powerful the explosion was. So for example, they've established that this explosion was generally more powerful than a similar explosion that occurred in Wyoming back in 1996 that, on paper at least, was a lot more powerful, truly making this tragic event one of the most powerful explosions, accidental non-nuclear explosions, that have ever occurred on the planet. Something that unfortunately most likely occurred because of the human greed, human incompetence, and complete disregard for human life. Something that could have been definitely avoided if the owner was more responsible, if he didn't abandon his crew and the ship, or if the authorities in the port disposed of the cargo immediately. But unfortunately, what's done is done. So let's just hope that something like this doesn't happen again. But because my personal interest in this was purely scientific, I encourage you to check out these papers by yourself, because there's actually a lot of interesting stuff in them, including some of the more interesting comparisons to some of the other big explosions in the past. And more importantly, they also provide us with a lot of really cool techniques on how the scientists were able to establish the total yield of this explosion by, for example, using the audio from certain Twitter videos that I showed you previously, and then literally calculating the approximate yield based on this information alone and the estimated distance from the location, which by itself is kind of mind-blowing. But on that note, well, check out all of the media and all of the relevant studies, including the Twitter videos, in the description below. Subscribe if you still haven't. Hopefully you enjoyed this video. Hopefully something tragic like this doesn't happen again. And, well, stay wonderful. Don't be like that guy who abandoned his ship and his crew. Be a wonderful person. Anyway, I'll see you tomorrow, and as always, bye-bye. Whoa, that looks kind of creepy. But that's basically the cosmic web. Hello wonderful person, today we're going to discuss this really cool idea once again, because yet another study discovered something unusual about this very mysterious and somewhat difficult to detect phenomenon. This cosmic web, as you might already know, is essentially what the entire universe is more or less made out of. And even though for the most part its existence is known through computer simulations, its actual presence has also been detected by different telescopes by investigating certain regions of the universe. And even as far back as 2014, the scientists were already able to detect certain observations that represented something that was originally simulated on a computer, which even back then suggested that the cosmic web is everywhere, and it also creates a kind of a gas flow across the universe, across different galaxies. with one of the more impressive images that we've discussed a few years ago being this one right here, showing the cosmic web that stretches millions and millions of light years across. And here's another one showing us something slightly smaller but also quite as impressive. But more importantly, the recent study and also some of these other studies of cosmic web allow us to answer a really important and somewhat mysterious question. The question of how galaxies can grow so massive so quick. Because, for example, according to various computer simulations, when the scientists do create these miniature universes in a box, what they generally observe is a relatively slow growth of galaxies, but some galaxies do grow a little bit faster, especially if there's a lot of cosmic web connecting to those galaxies and a lot of gas flowing through them. And this has been simulated many times in some of the bigger projects, including what's known as the Illustris project, which allow us to see how the universe evolved and developed across billions of years. But the important question here is still kind of difficult to answer. Why is it that we still find these really early galaxies, like even the ones we've recently discovered only a few months ago, where the galaxy itself is way too massive to exist so early and produces way too much energy, as if it has a lot more mass than we initially anticipated or predicted in some of the models. And so there's a bit of a disconnect between what we expect to find in the early universe and what we actually discover there. And the discoveries are very often extremely massive galaxies with extremely massive, supermassive black holes in the middle. And it's usually extremely difficult to explain the existence of these galaxies. They're clearly out there, but how could they form so quickly and acquire so much mass? And so this recent study that, as always, you can find in the description below, was able to identify this very distant galaxy known as SMM J0913, a galaxy that seems to be growing extremely fast, creating new stars approximately 1,000 times faster than the Milky Way galaxy, while at the same time also discovering several other quasars very close to this galaxy, which presented an excellent opportunity for scientists to try to figure out what happens in a neighborhood nearby. And mostly because what this allows the scientists to do now is take the light from the distant quasar and try to trace it as it passes through various types of gas on the way to Earth. And because these quasars in terms of the night skies are located very close to this galaxy, it allows the scientists to thus identify any kinds of gas or any kinds of motion very close to this particular galaxy. And in this case, they were able to discover once again the signs of this mysterious cosmic web and the signs of a lot of motion of gas headed toward the galaxy.
Head & Shoulders представя първия душ гел и шампуан 3 в 1. Коса, лице и тяло.
Itself. Now this starburst galaxy right here is about 2.5 billion years old, and the quasars next to it are very likely a little bit older because they're actually slightly more distant. And so we're kind of looking at this from the perspective of galaxy being right here, the galactic cosmic streams being right here, and the background quasars here shining their light, and as it passes through one of the strings of the cosmic web, we then get to detect it here on planet Earth. And so this presented the scientists with an excellent opportunity to try to figure out what this cosmic web is doing to this galaxy, but also try to figure out what it's made out of, what's inside of it, and where it's actually going. And the first major discovery here was that the cosmic web did not contain any metals, any heavy elements. So basically it's made out of this primordial material, mostly hydrogen, helium, maybe a little bit of lithium. And since no other elements, like for example no calcium, no aluminium, nothing else was discovered here, it really suggests that this material did not come from another galaxy. Typically, early galaxies will have a lot of supernova happening all over the place. And as these supernova happen, they're going to spew out a huge amount of material that's not going to be hydrogen, helium, and lithium. They're going to produce a lot of heavier elements, which should be visible if this gas came from any galaxy that had a lot of supernova. But since the gas that the quasars were shining through did not have any of these materials, there's almost no doubt that it did not come from a galaxy. It was an intergalactic gas, and they were also able to see that it was actually headed toward the galaxy itself. The gas here was definitely flowing toward the galaxy at a speed of about 300 kilometers per second, with the total rate of accretion of gas being about 100 masses of the sun per year. So basically this galaxy was absorbing about 100 masses of the sun through these galactic streams, or through this tremendously large cosmic web. And because a lot of this gas is funneled toward the galaxy, this would definitely explain how this particular galaxy was able to grow so extremely quickly and how it was able to produce so many stars. Approximately 1200 masses of the sun per year. And that's actually one of the highest values of star production we've seen in any galaxy. Which of course also implies that a lot of these early galaxies, especially really massive, really bright galaxies, very likely grow in a similar manner. The more cosmic webs are connected to them and the more inward flow they experience, the more likely they're going to be growing much faster. Which essentially kind of presents the picture of the universe as this really intriguing, almost like spider-like web, with each individual intersection being a galaxy that gets fed by a lot of material that passes through those particular strings. And also, according to the calculations here, a typical galaxy like this should really only need about 1 billion years to acquire enough mass to suddenly become a starburst galaxy with a lot of emissions all over the place. So basically some of these brightest galaxies very likely just experience a lot of inflow through the very beautiful galactic web that you see on the screen. And what's even more impressive about the study itself is that this team here apparently looked at close to 70,000 different galaxies before they discovered this one. So this was an extremely lucky discovery. It took them about 5 years to identify this target, and it was really the positioning of other quasars nearby that allowed them to study all of this in so much detail. But they only took at 2 quasars right now, so follow-up studies can actually investigate this area in more detail, because this galaxy might actually become a kind of a Rosetta Stone for trying to understand how the cosmic web works and for trying to identify what happens in these early galaxies to help them evolve and become the way they are. Now this is obviously how Milky Way grew as well, but because we're located inside the galaxy, it is practically impossible for us to try to see this cosmic web from within. You really have to look at this from the outside. And so with every single study that comes out about this cosmic web, we kind of start getting better and better picture of how the early universe evolved, and more importantly, we're starting to really understand how absolutely crucial this cosmic web is for the development of structure of the universe, for the development of every galaxy in the universe, and it also helps us understand that the galaxies themselves are really just the visible part of this really massive and humongous structure that stretches across the whole universe. And that's something that really makes you feel, well, small in one sense, but also interconnected with everything out there. But once we learn more about the cosmic web or discover something else really cool about it, I'll make sure to follow this up with another video. Until then, thank you for watching, subscribe if you still haven't, share this with someone who loves learning about space and sciences, maybe come back tomorrow to learn something else, maybe support this channel on Patreon by joining the channel membership, or by buying the wonderful person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye. So this is Miranda, one of the strangest moons in the solar system, and right behind it you're about to see one of the strangest planets, the planet Uranus. Hello wonderful person, this is Anton, and today we're going to be talking about some of the major discoveries from the last few months in regards to this beautiful planet that we actually still know so little about. But more specifically, we're going to be focusing on two major discoveries. One are the X-rays coming from this planet, and two are the studies in regards to the magnetosphere of this planet. And, well, let's start with the X-rays. With this beautiful picture right here, where the pink represents the X-rays, pretty much summarizing everything. Very recently, scientists studying the data from Uranus, the data collected over the years, actually over decades, by the beautiful Chandra X-ray Observatory, detected quite a lot of X-rays emanating from the surface of the planet and possibly even from the rings of this planet. And though it does sound unusual, it actually isn't, because Jupiter and Saturn also have been caught emitting X-rays in the past. But before we go on, well, let's start with the obvious, the rings. Yes, Uranus has rings, so does Neptune, so does Jupiter, and so does, obviously, Saturn. Even though generally we don't really think of Uranus as being a ring planet, it definitely is one, and you can even clearly see them right here in this simulation in Space Engine. But unlike the rings of Saturn, well, first of all, they're much smaller, but second of all, they contain different stuff on the inside. They're also extremely dark, very dark. And that's why it's so difficult to see them. Both Neptune and Uranus seem to contain somewhat similar rings, and unlike Saturn's rings, the rings of Uranus and Neptune are really dark, and I'll explain to you why, because it does relate to some of the recent discoveries we're talking about today. But since unfortunately Voyager 2 is the only probe to ever visit this system and was only here for a very brief period of time, we still have a pretty limited knowledge of these rings, and most of the studies in regards to these rings and what happens around Uranus for the most part has since been done by various telescopes such as Hubble, and so there are still a lot of things we don't really understand. But back to X-rays. So as I mentioned previously, we've detected X-rays coming from Saturn as well, and also from Jupiter. But in this case, the scientists believe that for the most part, the X-rays are very likely just the reflections from the upper atmosphere of the solar X-rays, or the X-rays that originally came from the Sun and then got reflected by the atmosphere of Jupiter and Saturn. And so some of these detections were very likely also quite similar. Some of these X-rays detected in the last few years probably also came from the Sun. But the scientists believe that not all of them came from the Sun. As a matter of fact, there's also a very likely possibility that the rings are also responsible for creating some of these X-rays. And we know that this is exactly what happens around Saturn. In the past, when studying Saturn, the scientists also realized that a lot of these X-rays were really coming from the rings and not just from the planet. And it was pretty clear to the scientists that a lot of this X-ray glow was actually coming because the rings were actively interacting with the magnetic field of Saturn, and as various energetic particles collided with these rings, they essentially created X-rays that were visible from very far distances. And in case of Saturn, most of this X-ray production was done by the charged electrons as they interacted with oxygen atoms located inside the water icy rings, which then ended up producing this beautiful radiation you see right here. And so if it can happen around Saturn, it's quite possible that it might also happen around Neptune and Uranus as well. But there's another possible source for this X-ray radiation, and that's the aurora, the so-called northern and southern lights. Now, originally the aurora on Uranus were detected once again by the Voyager probe, but they were also later seen by the Hubble telescope as well. And so we know that Uranus also has quite a lot of these aurora, or essentially these extremely powerful light shows, which do tend to produce X-rays as well. But the thing is, aurora on planets like Jupiter, and in this case Uranus, are not really produced in the same way as they're produced on Earth. The charged particles that produce aurora on Earth come from the Sun, but for Jupiter and Uranus, the charged particles actually come from the vicinity. They come from the interaction with the magnetic field, and very likely with a lot of other material, including the rings and the moons surrounding the area. And although today scientists generally understand how the Jupiter's aurora are made and have a pretty good explanation for what we're observing there as well, for Uranus, this is still a bit of a mystery. And mostly because the aurora and obviously the X-rays produced by the aurora directly depend on the magnetic field produced by the planet. And that's where we come to the second mystery and something that we don't really understand about both Uranus and Neptune. How is it that these two planets have such a strong magnetosphere, and what exactly generates it on the inside? So, for example, we know that for Earth, the magnetosphere is most likely generated by the circulation of the liquid iron core, where the churning of the electrically charged material produces the magnetosphere that we have on the planet. For Jupiter and Saturn, something similar happens on the inside, except that it's not really iron this time, but it's metallic hydrogen. As you compress hydrogen and as it reaches a certain condition, it starts having metallic properties and acquires charge. And so the churning of a tremendous amount of hydrogen on the inside generates really powerful magnetic fields around Jupiter and Saturn. But Uranus and Neptune have something completely different going on, and that's where the mystery for the scientists begins. And first of all, well, here's a comparison. Here's the Earth's magnetosphere, with north and south being just a little bit misaligned with the rotation of the planet. But for Uranus and Neptune, not only is it misaligned in terms of their rotation, but it's also not really in the center of the planet either. On Uranus, the angle here is about 59 degrees, on Neptune it's about 47 degrees. And for both planets, the center is completely off as well. In this case, it's about 13,000 kilometers away from the physical center of the planet. Yet at the same time, both planets still have an extremely powerful magnetosphere, much stronger than the one on Earth, with Uranus having the magnetosphere that's about double the strength of the one on Neptune. But what's really strange here is that because of this unusual alignment, the magnetic field in the southern hemisphere of Uranus is much weaker than the strength in the north, and something similar happens on Neptune as well. It's actually about 5 times as strong on one side compared to the other. And because of this strange misalignment of the magnetic lines compared to some of the other planets, every single day on Uranus, the planet's magnetic lines align with the solar wind coming from the sun, and because of this, the planet opens up to a lot of the solar radiation, which basically means that this planet and all of its moons get bombarded by the solar radiation at least once a day. And if something like this was ever happening around planet Earth, well, it's very unlikely that the life would ever evolve here. But since both Neptune and Uranus have these very strangely aligned magnetic fields, today scientists believe that maybe this is just a common feature for many different ice giants. Ice giants being these distant gas giants that are usually smaller in mass than Jupiter and Saturn. But the other question here is, of course, so what creates this magnetosphere and why is it so strangely shifted? Now, this currently has no answer, but in the last few years, scientists have conducted several different studies, including this recent study from just a few days ago, where they tried to recreate the materials we might detect inside a typical ice giant, specifically highly pressurized ammonia and highly pressurized water, and possibly some other ices as well, with the main goal being a creation of what's known as the super ionic water or super ionic ammonia, or really super ionic ice. In this case, this is actually related to one of the videos I made previously about the discovery of a new type of ice that you can find somewhere right there. But in a nutshell, what the scientists are trying to make is basically water or ammonia under extreme pressures, and they're trying to see if it actually starts changing its properties. With the current belief being that if, for example, one of these super ionic liquids starts becoming more viscous and starts to flow much slower, it might actually explain why there is such an unusual magnetosphere inside these planets. If, for example, let's just say ionic water becomes either really viscous in certain conditions or flows really easily in other conditions, this would suddenly allow the scientists to explain why there is such an unusual misbalance when it comes to the magnetosphere of these planets. So basically, let's just say this ionic water becomes really viscous if you suddenly change just a little bit of its pressure. This means that it's going to flow really easily on one side of the planet, but become kind of like honey, very viscous on the other side, which would create larger chunks on one side compared to the other side, which would also shift the magnetosphere to possibly one direction. But that's of course just a theory, a science theory. Okay, that doesn't sound as good as game theory. Anyway, the point is that even today, including this study, the scientists haven't discovered such properties. They tried this with ammonia, and superionic ammonia does not become viscous enough to explain any of these observations. Which of course once again means that currently we have no idea how these magnetospheres of ice giants are created. So the explanation here still involves a lot of ionic liquids, so possibly water, methane, maybe ammonia. But it's not really clear why exactly is it that it's so one-sided, why is it shifted to a single direction. Now it probably does involve these exotic ices and the exotic properties of these ices that I've discussed in the previous video, but the details and the explanation is just not there. It's still a really big mystery. But it's a mystery that's kind of worth solving, because if this is what happens inside these ice giants, it means that many of these ice giants somewhere out there in other star systems will probably have something similar going on. And this could be even true of some of these smaller planets, including what we refer to as a super-Earth. If these ionic liquids can form on surfaces of these other planets, they will probably start experiencing some really similar magnetic effects, with magnetic fields being very misaligned and possibly behaving in a way that we don't really expect them to behave. But for now, this is not a mystery anyone has an answer to. Which once again means that, well, there needs to be a mission to these planets, a mission to Neptune, a mission to Uranus, and possibly even more missions to study their moons. A lot of mysteries here, a lot of really cool explanations for how magnetic fields are generated in ways that are different from planet Earth and from planets like Jupiter and Saturn, and also a lot of other mysteries that will definitely help us, well, learn a lot about the universe, but also probably develop some new technologies that we never really thought possible. And so the fact that no one is actually planning any major missions here yet is unfortunate. But hopefully a space agency somewhere out there decides to launch something sometime soon, and hopefully we'll actually get to explore these planets in the next few decades. For now, well, that's pretty much all I wanted to mention in this video. There's some X-rays we detected. We also think that magnetosphere might play a role in the creation of these X-rays, but how the magnetosphere is generated around them is a question nobody has an answer to. Once we learn more, I'll make sure to follow this up with another video. Until then, thank you for watching, subscribe if you still haven't, share this with someone who has learned about space and sciences, and maybe come back tomorrow to learn something you might have not known. Also, maybe support this channel on Patreon by joining the channel membership or by buying the wonderful Patreon t-shirt you can find in the description. Either way, stay wonderful, I'll see you tomorrow, and as always, bye bye. So hypothetically, can a planet spin so fast that it rips itself apart? And well, according to one of the recent studies, the answer is quite possible. Hello wonderful person, this is Anton, and today we're going to be talking about a really interesting discovery of 3 brown dwarfs, or 3 really massive planets, that spin so fast that they're practically at the limit right before they fall apart. Something that naturally really surprised the scientists. But first of all, let's start with what's a brown dwarf? And there's actually one right there. Let's go and explore it. So a brown dwarf is what we would call a failed star. It's an object that's not really a star in terms of mass, and it doesn't really have an ability to fuse hydrogen, but it's really massive to be a typical planet. As a matter of fact, unlike planets, they start acquiring their own properties. So for example, the more massive the brown dwarf, the smaller it gets in size. This here is a lot less massive than this one right here. And as they get more massive, they start acquiring properties where they even start fusing certain materials. At first, the brown dwarf starts fusing deuterium and starts to produce a little bit more energy and more heat, and later on it even starts fusing lithium, which produces even more heat. But in order to become a star, a typical brown dwarf needs to acquire about 80 to 90 masses of the sun. And that's essentially when the brown dwarf sort of changes completely, the layers on the inside shift, and it starts fusing hydrogen, producing a lot of energy. But prior to about 13 masses of Jupiter, it's still considered to be a planet because it doesn't have a lot of these features. In other words, anything below 13 masses of Jupiter is still basically a gas giant. It's a Jupiter-like object. Some of the first discoveries doesn't have a lot of these features. In other words, anything below 13 masses of Jupiter is still basically a gas giant. It's a Jupiter-like object. Some of the first discoveries of brown dwarfs are basically a gas giant. It's a Jupiter-like object. Some of the first discoveries of brown dwarfs came from this beautiful telescope known as WISE that operated around a decade ago. This is the so-called Wide Field Infrared Survey Explorer that made a lot of really exciting discoveries, including this right here, the most famous brown dwarfs known as Loman 16. This is a binary object and is also the closest brown dwarf to us. And because this system are the closest brown dwarfs to us, it's been investigated and studied by various scientists, and one of the previous videos does actually explore this in more detail because we found some really incredible things about them. And in case you were wondering, this is how close they are to our solar system, with the next closest brown dwarf being right here, slightly farther away. But in the last few years, scientists have been discovering more and more of brown dwarfs, and a lot of them are really weird, really strange. Mostly because, as I mentioned before, they're not really planets and not really stars. They do possess a lot of their own features, but also because they are so numerous, there are so many of them out there. And because there are so many out there that have been already discovered, there are obviously some really interesting record holders as well. The smallest, the biggest, the closest, the most distant, and a lot of other records. But the one record that's particularly interesting to us, especially when it comes to the formation of planets, are the brown dwarfs that spin the fastest. Mostly because we would really like to understand one day how fast planetary objects can spin, and also what effects this might have on the object itself and some of the objects nearby. Although in this particular case this is a simulation, so nothing really spins that fast. But as the recent paper that you can find in the description below discovered, there are at least 3 objects out there, 3 brown dwarfs out there, that spin so fast that if they were spinning just a little bit faster, they would most likely start losing chunks of the matter from the surface. So basically they're spinning almost at the limit of how fast a planetary object can spin. But how fast is fast? Well, here's a comparison with planet Earth and with the fastest spinning planet in the solar system, Jupiter. As you might know already, Jupiter makes a single spin around its axis every 10 hours, and that's really fast for the solar system. Naturally, Earth takes 24 hours. But one of these beautiful giants, one of these brown dwarfs discovered, with the average mass of approximately 43 masses of Jupiter, only takes just a little bit longer than an hour to go around its axis. And that's absolutely mind-blowing. Which also probably creates some ridiculous effects on the equator. Now first of all, because of the centrifugal forces here, it's very likely that the object probably looks something like this. Very disc-like. And because of these ridiculous speeds, it's also very likely that the brown dwarf itself, especially if we look at it from the top here, might constantly lose a lot of matter to the outside. Now it's not really clear what happens to this matter as it sort of escapes and as it starts spewing out from the sides here, but it very likely comes back to the planet, to the brown dwarf, and possibly deposits in the polar regions or somewhere else where the spin is not as high. So for all we know, it might resemble something like this, although that's just a speculation. Basically here, if the matter does actually leave the surface of the planet, it will probably get deposited in some of the other regions of the brown dwarf. But before we go on, let's make this object look a little bit more realistic. Now remember, these objects don't just spin rapidly, they're also very massive. This one here is over 40 masses of Jupiter, which means that it can easily maintain its shape. It can maintain its spherical shape a lot more efficiently than other planets. And because of this, its actual ablateness is not as extreme as I made it seem, with the predicted value for how ablate this object is being around 0.08, or about 8% as squished as a typical sphere. So from a distance, it's still going to kind of resemble a sphere, but I figured just for the artistic reasons, it's still more fun to keep it squished just so that you can remember how fast it really spins. And so the mass of this object can easily maintain its spherical shape. It's even less ablate than Saturn, which spins much slower but has much lower mass. But naturally, because it spins so fast, it also probably has extremely powerful magnetospheres. That's one of the potential effects that all of this generates. And since we know that Jupiter already has the most powerful magnetosphere of all the planets in the solar system, magnetosphere that's formed by the metallic hydrogen on the inside, that's also generated through the relatively fast rotation of the planet, by having such a ridiculously powerful rotation in these brown dwarfs, the magnetosphere is probably so much stronger. And what potential effects this generates around these brown dwarfs is actually not something we can currently answer. But one potential effect that we can definitely detect in the future are very powerful aurora. Probably even some of the most powerful aurora we've ever seen. And since the nearest of these objects is only about 29 light years away from us, this presents the scientists with an excellent opportunity to study what happens around these extreme objects with extremely powerful magnetospheres. And in case you were wondering how fast you'd be moving if you were to somehow find yourself on the equator of this object, well, basically by standing right here, you would be spinning around 110 kilometers per second, plus minus a few kilometers. And that's really fast. That's way faster than, well, actually way faster than anything we have in the solar system for sure. And also generally about 10 times faster than a typical brown dwarf. Which of course means that these objects are some of the most extreme objects in the galaxy. But considering how dim these objects are, and also considering the distances here, how could the scientists possibly know the rotation of these brown dwarfs? And to identify the rotation, the scientists use a really interesting and somewhat brilliant technique. And here's how they reasoned. We understand that pretty much all gas giants have all kinds of weather storms on the surface. The most famous, of course, being the Great Red Spot right here. And generally, these large weather storms will probably produce slightly different visible wavelengths as the light from the planet, or from a brown dwarf in this case, is emitted over a certain period. So for example, if we were to look at Jupiter, we would most likely see most of Jupiter look like this, and then once in a while, every 10 hours, we would suddenly see this unusual dip of light because of the Great Red Spot. This would happen quite regularly, and this would be very visible even from faraway distances. By using this technique, we can then kind of establish that it's very likely that all of this is due to the rotation of the planet, and it means that the planet spins every 10 hours. And so very similarly, the scientists studying these brown dwarfs identified the patterns that were repeating pretty much every single hour, something that became more and more obvious as they started to analyze the data. And since nothing can really spin around a brown dwarf that fast, the only other explanation is that it was the brown dwarf itself spinning every hour. But although most stars, planets, and brown dwarfs discovered so far usually have the spin around 10 hours, which is very similar to Jupiter, these three objects were unique and they were very unusual. By the way, on the opposite side of this extreme is actually our Sun, the most important object in our solar system. And unlike other stars, our Sun spins really slow, and also because of this is one of the mildest stars out there. And this is of course one of the main reasons life was able to evolve on our planet, and very likely will have difficulty evolving in some of the other star systems. A single rotation of the Sun takes roughly around 27 days. Although to be more exact, it actually varies depending on where you're looking. If you were to look at the equatorial regions, the rotation here would be around 25 days, whereas in the polar regions the rotation is closer to about 35 days. And just to confirm that this was actually the spin of the object and not really something spinning around the object, the scientists also were able to see the blue shift of the side coming toward us and the red shift of the side coming away from us, suggesting that what they were observing were the Doppler effects from all of the light coming from these three brown dwarfs. And so there's very little doubt that what the scientists discovered were indeed some of the fastest spinning objects in the galaxy. But now the next questions are going to be in regards to trying to analyze what happens around these brown dwarfs, with the obvious questions being in regards to the magnetosphere, the potential effects on planets orbiting around these brown dwarfs, and maybe even some other mysterious effects we can't even imagine just yet. But a lot of them are probably going to be in regards to the magnetosphere, or possibly even some of the gas escaping this object as it spins really fast. And so either way, it's an exciting discovery, and we're definitely going to be coming back and talking more about this as the scientists discover more about these really strange, really peculiar objects. But considering how many brown dwarfs are out there, and considering that our techniques of discovering new things about them have been improving over the last few years, chances are we're going to find even more strange objects out there in the next few years. So make sure to subscribe, because there are going to be so many other videos coming about these peculiar and somewhat difficult to understand objects. But on that note, thank you for watching, hopefully you enjoyed this video. Maybe support this channel on Patreon by joining the channel membership or by buying the Wonderful Person t-shirt you can find in the description, and maybe come back tomorrow to learn something else. Either way, stay wonderful, and as always, bye bye. Oh, another thing we need is a really cool name for these objects. Right now their name is somewhat challenging. For all three objects, it's basically something like this. And so if you have a really cool name or a cool idea for these objects, post it in the comments below. As long as that idea is not like brown like spinny face or something, because that just doesn't sound right. Anyway, bye bye. So this is Miranda, one of the strangest moons in the solar system, and right behind it you're about to see one of the strangest planets, the planet Uranus. Hello wonderful person, this is Anton, and today we're going to be talking about the object known as Theia that approximately 4.5 billion years ago collided with planet Earth, eventually resulting in the formation of our beautiful moon. And despite this being a pretty well accepted idea today, there are still a lot of questions about this whole scenario. For example, what happened to the rest of Theia? Did it actually collide and get absorbed into Earth, or did some of it escape into some other area of our solar system? And if so, where exactly is it located today? And so in this video we're actually going to be discussing a very interesting proposition that makes a lot of sense. Theia is indeed inside our planet Earth. And it actually explains one of the phenomena we have inside our planet that we've discovered a few years ago, but that has since been sort of mysterious and extremely difficult to explain, because it does create a lot of really unusual properties on our planet. The objects known as LLSVPs, also known as Large Low Shear Velocity Provinces. But let's go back in time approximately 4.5 billion years ago and start with the idea of Theia. So today a lot of scientists believe that Theia was most likely in a very similar orbit to planet Earth for at least a few million years, possibly even 100 million years. It was very likely located right here in the so-called L5 Lagrange point, which are these stable orbital points where you can place a satellite, for example, and it's going to stay there without falling into the sun or falling back to planet Earth. And as a matter of fact, several satellites today are in those points. And in these Lagrange points, we also usually discover a lot of different Trojans, like the ones that Jupiter has, and so finding a large massive object there is not unusual. But it's still quite easy for an object in a Lagrange point to lose stability and to eventually start moving around the orbit and possibly even collide with one of the other objects. So for example, for satellites, we do need to maintain their orbits to make them stable. And so approximately 4.5 billion years ago, the scientists believed that this is exactly what happened to Theia and to planet Earth. Theia itself being roughly the same size as planet Mars, and Earth being a little bit smaller than it is today, with the impact itself first creating a kind of a disk of debris, which then slowly coalesced, creating the moon. But this is a somewhat simplified picture, and you might already see a problem here. The mass and size of Theia is a lot larger than our own moon. So where's the rest of this object? At the same time, how certain are we that this is exactly how the moon was created? What other proof do we possibly have showing us that this so-called collision occurred approximately 4.5 billion years ago? And even though the direct evidence for this event is a little bit difficult to find, over the past few years, scientists did discover a few hints suggesting that this collision did indeed occur, but more importantly that Theia chunks, those leftovers of Theia, are actually still around. And more specifically that those Theia chunks did not disappear, they did not go into the other parts of the solar system, they stayed on planet Earth and sunk to the bottom. And as you probably guessed by now, those chunks are what you see right here on the screen. They are indeed those LSVPs that scientists discovered a few years back. Now, in case you don't really know, these LSVPs were discovered by using this technique known as seismic tomography. And the way the technique works is by listening to different earthquake waves and the speed of propagation of those waves, and then comparing the waves, forming the overall picture of what the waves most likely pass through. By using this technique, the scientists can usually very accurately see what happens inside planet Earth and also detect various objects that would be otherwise invisible to us. And so by using seismic tomography, long ago the scientists discovered these unusual formations inside our planet. And unfortunately, even today, it's not entirely clear how they were formed. But the original explanation was that they were more likely to be possibly ancient continents that sunk to the bottom of the planet. But that proposition doesn't really explain a lot of things, especially because why is it that these continents sunk but the other ones stayed on the surface? At the same time, several studies that were analyzing volcanic rocks in Iceland identified some of the samples resembling these LSVPs and were able to measure their density, discovering that their density was about 2 to 3% more dense than mantle of our planet. And obviously, because this stuff is more dense, it would sink to the bottom, depositing on top of the outer core. Interestingly, 2 of these blobs located beneath Africa have been implicated in the formation of the so-called South Atlantic anomaly, which is this relatively large magnetic hole present in the region around South America, where the magnetic field becomes so weak that even satellites passing through here do have a tendency to malfunction or even become damaged. And so the scientists today think that this part right here very likely formed because of the LSVPs present in the area right here. So basically we have these very mysterious, dense objects inside our planet whose origin is somewhat difficult to explain. But what is certain about them is that they've been around for a very long time. As I mentioned previously, that study that discovered those rocks in Iceland also discovered that these mantelpieces were extremely old, possibly even older than the moon itself. And if we find a piece that's older than the moon, it only suggests one thing. It most likely came from that mysterious Theia. At least that's the implication that the scientists whose paper you can find in a description make after a relatively thorough analysis. The main idea, of course, being the fact that after the moon was born, the chunks of Theia eventually stayed inside our planet and sunk to the bottom, forming these LSVPs, and the remnants of Theia are still there today, which of course would explain why we don't see Theia orbiting somewhere in the solar system and why we don't actually have any asteroids or any meteorites landing on the planet that might have been from Theia originally. And there's quite a lot of good evidence that the scientists do provide in this paper. So for example, we know that if we were to combine the mass of LSVPs, which is about 2 to maybe 6% of mass of planet Earth, and add them to the mass of the moon, this does give us the average value for the prediction of the total mass of what Theia was probably like as well. At the same time, the predicted value for the density of Theia does actually come really close to the total value of density we discover inside of those LSVPs. The scientists today believe Theia was slightly denser, possibly about 2 to 3% denser than planet Earth. And so the explanation presented in the paper is that, well, once you combine Theia and the early Earth, you'll get these chunks of Theia stuck inside of the mantle of planet Earth, which will eventually solidify and form the regions that do resemble LSVPs that we find on the bottom of the mantle of our planet. And because denser material usually sinks to the bottom, that's basically why the LSVPs were formed. Theia's mantle was just denser to begin with. With these pieces here representing some sort of an iron-rich and possibly highly dense mantle, slightly more iron-rich than the mantle of planet Earth. And all of this also connects to a lot of other discoveries that suggested that these really ancient LSVPs have approximately similar age to the original impact with Theia, with all of these studies together now giving us a pretty clear picture of what probably happened about 4.5 billion years ago. So let's try to summarize. We had two objects in the same orbit, with one of the objects becoming destabilized and eventually colliding with planet Earth, with the collision itself creating quite a lot of debris orbiting around the planet, with the other parts eventually settling inside the mantle. The debris on the outside solidified and created our beautiful moon. But the pieces on the inside were much denser and eventually sunk to the bottom of the mantle, forming what we know today as LLSVPs. The mysterious, dense, and extremely massive pieces of planet Earth that is otherwise difficult to explain. The total mass here is between 2 to 6% the mass of planet Earth. And overall, this explanation actually does solve a lot of different mysteries we've had about our own planet. But whether this is a correct explanation, or whether some other explanation is going to be provided in the future, well, only time will show. For now, honestly, this is actually pretty brilliant and explains quite a lot. But in the last few months, we've made a lot of really awesome discoveries about our own planet, and so check out some of the other videos I made on the channel that should be popping up somewhere right there, that talk a little bit more about the inner core and some other really cool discoveries in regards to the cooling of planet Earth. On that note, thank you so much for watching. Hopefully you know a little bit more about planet Earth now, and hopefully you enjoyed this video. Subscribe if you still haven't, share this with someone who loves learning about space and sciences, maybe come back tomorrow to learn something else, and maybe support this channel on Patreon by joining the channel membership or by buying the wonderful % t-shirt you can find in the description. Either way, I'll see you tomorrow, stay wonderful, and as always, bye bye. Hello wonderful person, this is Anton, and today we're going to be talking about biosignatures and possibly even technosignatures. The idea behind being able to detect life somewhere out there outside of planet Earth. But I wanted to start right here, Venus. This is actually what Venus looks like when you remove all of the atmosphere. And as you probably remember from around a year ago, there was a lot of excitement about Venus, mostly because of the potential discovery of what's known as phosphine, the somewhat toxic gas that's usually produced by life here on Earth, and that is sometimes also produced in some really extreme conditions on Jupiter and Saturn. Now, whether the phosphine was really detected or not, that's really the question for another video, but the idea of finding these biosignatures on other planets is one of the most exciting topics in what's known as astrobiology, trying to discover something out there living on another planet far away. Now, in the past few years, NASA and a lot of other scientists have already proposed a lot of different technosignatures that's for finding extraterrestrial intelligence somewhere out there, and they've also identified a lot of different biosignatures as well. But a study that just came out might have identified another really important one, something that a lot of scientists kind of thought about, but never really thought about it in that way. And that's a compound or a molecule known as isoprene. A molecule that sort of looks like this, with the general formula being C5H8. And just like methane, isoprene is an extremely abundant organic compound here on the planet. And it's so abundant, as a matter of fact, that even we produce it all the time. Even as I'm speaking to you right now, I'm breathing out a lot of isoprene in my breath. But there's a big chance that you might have never heard of isoprene, mostly because it's not really a compound that's normally talked about much, even though it is absolutely abundant everywhere. But we've all used stuff made from isoprene, even when we're little. Isoprene is essentially what we refer to as natural rubber. It's that stuff that's produced from the trees in several countries around the world, with the biggest producer, I believe, being Indonesia, and it's basically that white stuff you see coming out of the tree. Or to be more exact, this is known as latex, and inside of it there's quite a lot of isoprene. But even though this might look like something that we never really experience ourselves, it turns out that isoprene is actually everywhere around us. Every single tree, every single bush, every single plant, and a lot of different animals produce isoprene all the time. And what's even more surprising is that as much isoprene is produced by various things on Earth as methane. And just like methane, this is what's known as a secondary metabolite. Or in other words, it's produced as a kind of a leftover from some of the reactions. But most of the isoprene does come from trees. Forests, and specifically deciduous forests, seem to be the biggest producers of this molecule. Now it's also produced by bacteria, it's also produced by animals, and a lot of other plants, but forests produce the largest amount of isoprene on the surface. Which is really interesting because the majority of the so-called secondary metabolites for animals usually come out as methane, whereas for trees it seems to be isoprene. But since it seems to be produced by a huge amount of different animals, different plants, and a lot of different things on the planet, it sort of makes sense to assume that isoprene might actually have this function somewhere else out there on another planet where life might evolve as well. And because isoprene is just as abundant as methane, it should also be relatively easy to detect it. But there is a small problem, at least with isoprene on planet Earth. Isoprene does not last very long when there's a lot of oxygen around. And so even though a lot of isoprene is released by trees and by a lot of animals, it usually doesn't last very long as soon as it comes into contact with oxygen and it turns into something completely different. But what if we're looking at a planet that doesn't have any oxygen, such as the primordial version of planet Earth? Those planets, if they do have a lot of early life on them, might actually suddenly have a lot of isoprene in the atmosphere as well. And because of this, scientists in this particular study that you can find in the description below realized that unlike on Earth, where isoprene is broken down into all of this other stuff you see right here, on these other distant planets, especially if they have early, still developing atmosphere, where life might have just started or maybe never evolved photosynthesis to produce oxygen, there might be a lot of isoprene in the atmosphere of those planets. And since, unlike for example phosphine, we don't really know of any inorganic ways of producing isoprene, it means that if we find any molecules present in the atmosphere of these planets, or let's just say we find some molecules present in the atmosphere of Venus, it will definitely mean that life is producing it here and not volcanoes, not some strange chemical reactions. And so I guess in some sense it's great news. We should probably jump onto this and start looking for isoprene on other planets. But it's not that easy. Mostly because it's still very difficult to detect. The scientists in the paper also mentioned that we need at least 10 times more isoprene in the atmosphere of a planet we're looking at before we can even identify its signatures using modern telescopes. Now they do mention that some of the future telescopes like James Webb Telescope or the Nancy Roman Telescope might be able to identify these signatures much easier, but at the moment we still need to have much stronger signature before we can find anything. At the same time, unfortunately, isoprene has a very similar signature, and we're talking about spectroscopic signature, to some of the other organic molecules, including methane. And actually several other hydrocarbon molecules do seem to possess a similar signature to this. With the basic comparison visible right here, the black is isoprene, with the other molecules represented in different colors. And so determining if what we're looking at is isoprene is still a bit of a challenge. But once again, future telescopes, especially the Nancy Grace Roman Telescope that's going to become operational in 2025, are going to have enough power to allow us to definitively say what it is that we're looking at. But chances are that one day we might actually find a planet somewhere out there with a lot of isoprene in its atmosphere. And what exactly isoprene is going to be doing in that atmosphere, that's of course a question we cannot answer right now. For example, we know that on Earth it does tend to form this somewhat strange, somewhat transparent liquid that does have a tendency to evaporate pretty quickly. But in certain conditions on certain planets, especially if there's no oxygen present in the atmosphere, it might be able to form lakes, it might even be able to form oceans, and might even have similar function to how methane functions on the objects like Titan, creating some sort of an unusual liquid cycle with rain, oceans, rivers, and everything made out of isoprene instead of water. And considering the fact that there's just as much isoprene on the planet as there's methane, as you see in this particular graph from the paper, I really don't think that this is a far-fetched assumption. For all we know, maybe even on early Earth, isoprene could have formed some sort of a strange liquid on the surface. But in case you're wondering what exactly does it actually do in the trees and why do we have so much of it everywhere, well, that's not really a question that's easy to answer. For example, for trees, it seems to be associated with some sort of a mechanism that prevents abiotic stress. For example, heat stress. With one explanation suggesting that when the temperature becomes really hot, maybe around 40 degrees Celsius, isoprene helps stabilize the membrane inside the leaf cell and thus protects the plant from various heat stresses. And then during nighttime, when the temperature is cooler, a lot of this isoprene is then released into the air. But interestingly, even we currently produce isoprene. Approximately 17 milligrams per day of isoprene is released from your breath. Apparently it's the most abundant hydrocarbon inside our breath. And that is very difficult to explain. It's not entirely clear where it's coming from. It could be from our diet, it could be actually from the plants we're eating, but it also could be from the bacteria inside our bellies, or from something entirely different we don't currently understand. And so considering that it's so ubiquitous, it seems to be present everywhere, it doesn't really take much to imagine that there should be a planet somewhere else out there that is going to have very similar conditions with a lot of isoprene on the surface produced by various extraterrestrial life. But until we discover isoprene somewhere out there, and until we understand what exactly happens to isoprene inside our own bodies in order for us to produce so much of it, that's pretty much all I wanted to mention in the video. Check out the paper in the description below, subscribe if you still haven't, share this with someone who has learned about space and sciences, and maybe come back tomorrow to learn something else. Maybe support this channel on Patreon by joining the channel membership or by buying the Wonderful Person t-shirt you can find in the description. Either way, I'll see you tomorrow, stay wonderful, and as always, bye bye.
Head and Shoulders
Hello wonderful person, this is Anton, and today we're going to be talking about some pretty interesting and pretty major discoveries coming from within our own planet, within planet Earth. And considering the fact that nothing new has really been discovered about planet Earth, I guess I could say in the last few decades, this is a pretty big discovery and something that a lot of scientists are still having trouble to explain. And this recent discovery suggests that there is actually another part of our planet on the inside that we never really knew about. The core inside the planet seems to have another core on the inside, with the major implication being that the school textbooks might need to be rewritten because the structure of planet Earth is different from what we always believed. And that's on top of some of the other major discoveries from the last few months that I'm going to be briefly mentioning in this video as well. But first, well, how do we even know all of this? Well, to detect what's happening inside planet Earth, for generations now, scientists have used an extremely brilliant technique. They essentially listen to the propagation of different waves created by different earthquakes around the planet and try to compare the speed it took those waves to travel across the planet from various locations on planet Earth. And so this video from Incorporated Research Institutions for Seismology kind of shows you the brief animation of how all of this works. After the earthquake occurs, the waves travel in different locations on the planet, they generally also curve, and depending on the speed of arrival, the scientists can then calculate what exactly is happening inside the planet. And specifically, this also allows scientists to discover if there are certain regions inside the planet that are, for example, not really uniform, or if there are certain regions that are much bigger than others. And in the past, they've discovered some really cool things in there, but nobody really knows what's going on yet. And so one example here are these unusual blobs of matter that seem to be present in certain location inside our mantle. And these blobs are really huge, but nobody really knows what they're doing there and what exactly made them form as well. And there's actually quite a lot of them, as you can see in this animation. And today they're known as LLSVPs, or Large Low Shear Velocity Provinces. And considering that they represent about 6% of the volume of the planet, their creation story is one of the bigger mysteries right now. And as you'll probably learn from another video really soon, we might have actually solved their mystery once and for all. But I'm not going to spoil it here, although let's just say that it does involve a pretty interesting event and a pretty interesting object from the Earth's history. But I'll be talking about this in a few days when I release that video. For now though, that's just one of those discoveries made with the seismology detectors and by studying how the waves propagate in our planet. But this new discovery that was recently made was done by using data from a lot of different seismology detectors around the planet, and in this beautiful picture you can actually see how many of them there are already, with a tremendous amount being located in North America and in Europe. And then by combining all of this data and putting it all in a really complex algorithm to try to see if they discover something new, which can also be roughly visualized as this right here, with every line here representing various waves traveling across the planet when earthquakes occurred. And to their surprise, the actual detection and the actual mystery in a sense came from really deep inside the planet. It came from the inner core. Now just a quick reminder, generally prior to the study what we believe the planet is made out of is the crust on top, which is the layer we're walking on right now, and the layer where all of the mountains are. This is usually a layer that's about 7 kilometers deep in the oceans and can be up to about 40 kilometers deep in the continental region. So this is the thinnest layer we have. Beneath that is the largest part by volume, and that's the mantle, and that's where we discover a lot of different minerals, a lot of different stuff, including actually a hidden water deposit from some of the ancient water that used to be on the planet. So a lot of the water, if not most of the water, is present inside the mantle. And that's also where you find those mysterious blobs I mentioned previously. They're basically kind of at the bottom of the mantle, in some cases even touching the next layer, which is the outer core. And this outer core, for the most part, is believed to be liquid, and it's believed to be liquid metal, specifically nickel and iron. And by churning around, by spinning around, and by moving across the planet, we believe this kind of generates the electric field and thus produces the magnetosphere that our planet has. That's so far the best explanation we have for why the planet has the magnetosphere. But then, as all of this gets really squished and pressurized, all of this starts to become hardened and turns into a solid, and that's where the inner core comes in. And so previously we all believed that inner core was essentially this really large chunk of metal, really hot, really pressurized metal. But the earthquake waves passing through this region seem to actually be deflected slightly differently depending on the location they pass through, as if the inner core contains two layers, and that's basically the major discovery from the study. And although previous detections did actually suggest there might be something unusual going on inside the inner core and there might be another region inside of it, this is the first time it was officially confirmed using the data from various seismic monitors on the planet. And to be more exact, what the scientists found is that one of these cores has the iron crystals oriented east to west, whereas the other part of the core has a lot of these crystals oriented north to south, which suggests that they crystallized or became solid during different times or during different eras of planet Earth, as if some major dramatic event early in the history of the planet caused one of these layers of the core to melt and then re-solidify again in different formation. Or in other words, what this suggests is that the core itself, the inner part of the planet, might have cooled down during two separate events. It had a first event when some parts cooled down, then something happened and everything got heated up again, and then it cooled down again, crystallizing in a slightly different formation. And although right now the best possible explanation is that maybe this was due to the same collision that created the moon approximately 4.5 billion years ago, at this point nobody really knows what exactly happened to form this unusual layer on the inside. But that's just one of the major discoveries coming from the last few months ago. Another study actually reported something else really interesting that might relate to some of these discoveries as well. What the scientists discovered in this other paper, released only a few weeks prior, is in regards to how our planet cooled to begin with. They actually discovered a very interesting fact that suggests that the planet cooled down differently depending on what was on the surface, which kind of makes sense, I guess. So we know that oceans will also have much thinner crust underneath them, and because of this they actually cool down much faster. The continents, on the other hand, have much thicker crust, and at the same time, because of the rocks on the surface here, all of this cools down much slower. And so the interesting discovery here was, first of all, that the planet was kind of cooling down by about 150 degrees every billion years, but the unusual discovery here is that the planet was cooling down much faster where there was water, suggesting that the Pacific region of the planet, where there's a huge Pacific Ocean, cooled down by roughly around 50 degrees more in the last 400 million years, with the side where Europe and Africa are present cooling down by essentially 50 degrees less. And because this would obviously cool down the mantle underneath much more, this could obviously provide some explanation to why there are these unusual chunks inside our planet, and these chunks to some extent could maybe explain why our planet seems to also contain different regions of the core that cool down differently as well. But at this point all of this is just pure speculation, and for all we know none of these events are connected at all. They could be all separate observations with their own separate explanations. At the moment, nobody really knows what's happening here. The scientists are only certain about the fact that the planet cooled down differently depending on what was on the surface. And in this case, it's really interesting to find out that the Pacific region cooled down so much more than the rest of the planet. We don't really know what effects this would produce yet, but it would definitely produce some kind of a cooler and possibly even less mobile part underneath this, thus create a planet with a slight asymmetry. Now that, by itself, could produce some unusual effects that we're observing elsewhere. But until further investigations and until follow-up studies, which will hopefully come in the next few months, there's really no clear answer for any of this just yet. These are still cool papers and cool discoveries, and it's interesting how all of this came very recently, but so far these are just observations, no explanations. So until we know what's going on here, and until someone can actually explain where all of this came from, let's just leave it at that. And so once there's an explanation, I'll make sure to follow this up with another video. But there's also going to be another video that will hopefully explain to you one of the best possible explanations for what these large chunks are, at least in my opinion. This will be coming in the next few days, so make sure to subscribe, share this with someone who loves learning about space and sciences, maybe come back tomorrow to learn something else, and maybe support the channel on Patreon by joining the channel membership or by buying the Wonderful Person t-shirt you can find in the description. Either way, I'll see you tomorrow, stay wonderful, and as always, bye bye. Hello wonderful person, this is Anton, and today we're going to be talking about new discoveries and a new study that suggests there's a new resolution to what may have happened to water on Mars. And this particular resolution relates to another video I made not so long ago that made some really incredible discoveries about waters of planet Earth. And in some sense, these two studies relate to one another, explaining both planets really well. But let's start one step at a time. Now first of all, we know Mars definitely had water. simply based on the observations from various satellites that have found several different signs of ancient rivers and even signs of ancient tsunamis that most likely happened on the planet when some sort of an asteroid collided with one of the poles of Mars. We've actually talked about this in one of the older videos on the channel as well, and so the presence of ancient water on Mars is not really questioned by many. As a matter of fact, most scientists definitely agree that Mars had a very large ocean that covered a pretty large part of the planet, something that might have made it resemble this a few billion years ago. But the question is, of course, how did this water disappear, and what exactly happened to the planet to make this water all suddenly vanish over the past few billions of years? Now, the most common explanation today involves our sun and the lack of magnetosphere on the planet. Essentially, Mars lost its water, probably atmosphere as well, simply because the magnetosphere of the planet disappeared and was no longer able to protect the planet from the dangerous radiation from the sun, specifically various types of solar wind that can easily strip the planet of a lot of different particles on the surface. And because this has been measured many times, this is sort of a fact as well. But here's the thing though, was this the only process responsible for the loss of water on Mars, or did something else happen? And how much water was there present to begin with? Which is actually where this study comes in and provides some really interesting and somewhat fascinating answers. With the main summary of the study being that it wasn't just the solar winds. A lot of water was also trapped inside Mars itself, very similar to how a lot of water got trapped inside our own planet, and a lot of water is still there today. But the way that it was trapped is kind of interesting. So first of all, we still don't really know exactly how much water Mars had approximately 4 billion years ago. There is, however, a lot of speculation that early Mars very likely looked like modern Earth, although possibly also with a lot more ice cover on the surface and very likely with climates similar to what we have today in countries like Iceland. But once in a while this ice would melt and would create a global ocean as well. Today, however, all of the water is gone on the surface and only some water is still present at certain locations near the poles, with possibly some water being underground as well, with at least one lake previously discovered there. And so naturally the previous explanation using the sun as the culprit for the reason why Mars has no water made a lot of sense. And actually still makes a lot of sense, but the problem is we still don't really know how much of the ocean was present there, and we don't really know how much of the ocean was lost to the sun effects and how much of the ocean was lost to something else. But based on a lot of observations from the NASA mission known as MAVEN, the scientists over the past few years learned a lot about the interaction between the sun and the Martian atmosphere. Specifically here, they learned how the water vapor in the air of Mars is bombarded by various ultraviolet radiation from the sun, and how a lot of this interacts, eventually causing the hydrogen getting stripped from oxygen and essentially the water molecules breaking apart and escaping from the planet. Mostly because hydrogen inside water is a very light gas by itself, and so it's not going to stick around the planet and essentially escapes into outer space. But today we know that there is an isotope of hydrogen known as deuterium, and certain parts of water will contain this deuterium in there as well. Because deuterium is almost exactly double the mass of simple hydrogen, it's more likely to stick around and is more likely to actually remain on Mars, thus deposited in some sort of a rock or somewhere else where we can later find it. And because scientists today know the general ratio between hydrogen and deuterium in normal water, we can normally determine or estimate the presence of water on early Mars, or really anywhere else for that matter, using this technique. In other words, by comparing the number of deuterium to hydrogen atoms found in a certain sample, the scientists can usually estimate the total amount that was originally present in, for example, a certain sample somewhere else. And so by using various samples from various Martian asteroids, and by examining the amount of deuterium compared to hydrogen in them, the scientists were able to estimate that the total amount of water must have been much larger, and the amount of water present versus the effects we're observing with missions like MAVEN are almost impossible to explain if only the sun was responsible for making Mars lose all of this water. It just doesn't lose enough water through the interactions with the sun. Something else must have happened to essentially have all of this water disappear somewhere. And the best explanation here comes from some of the younger samples that are less than 3 billion years old. For some reason in those samples, it's obvious the water has already disappeared. which suggests that the drying of Martian surface must have happened within about 2 billion years or so. It was a relatively quick event. And well, it just so happens that there is a pretty solid explanation coming from this other study about planet Earth, the minerals inside Mars, and specifically minerals tend to absorb more water as they cool down. We've briefly talked about this in the previous video when I discussed this mineral right here that's very prominent in the mantle of planet Earth, the mineral known as ringwoodite. It just so happens that this thing right here is able to absorb a lot of water as it cools down. Or if we look at this from a perspective of a planet that was just born, as the early planet like Mars or even Earth cool down, and as the entire planet starts to slowly solidify and starts to produce all of these minerals, at some point a lot of these minerals will actually start slowly absorbing the water that's currently present on the surface. Okay, in this case it's actually a little bit too hot for water to exist. Here's a slightly more realistic scenario. So we have some liquid water here, and this water starts to slowly get absorbed by the minerals like ringwoodite, mostly because they tend to increase their absorption value as they become cooler and cooler. They're basically like sponges in a sense. And all of this water slowly starts to combine with minerals and eventually gets deposited deeper and deeper into the ground itself. Now on Earth, because of plate tectonics, some of these minerals will eventually release the water through volcanic activity. But on planets like Mars and possibly even Venus, where we don't really think plate tectonics ever existed, well, on these planets, it's a lot more difficult for a planet to recirculate the water back into the atmosphere, and so a lot of it stays inside and slowly gets soaked into the planet itself, with a lot of water possibly disappearing as quickly as within about 500 million years, simply because Mars is a much smaller planet, so it also cools down much quicker than planet Earth. And so these minerals soaked in a huge amount of water, anywhere from 30% to up to about 99% as estimated in some of these studies. And this would hypothetically give Mars these early oceans that could be as deep as 5,000 feet or roughly around 1.5 kilometers. So essentially these huge oceans must have existed here, but slowly disappeared because of the way that the rock absorbs water. And because all of these hydrated minerals were mostly older rocks, with none of them being younger than about 3 billion years old, it means that Mars lost water really quickly. Also, of course, implying that Mars looked like this for possibly a pretty long time, possibly over 3 billion years actually. And the results from the study also resolve a lot of different mysteries, including the discrepancy between deuterium and hydrogen, including the calculations from the amount of water stripped from Mars today and the discrepancy between the expected amount and the amount observed, and also huge rivers and huge seas and oceans that used to be present on the surface, which would not really be possible if Mars had just a little bit of water like some of the early studies predicted. And the implication here is of course that a lot of this water, possibly most of the water on Mars, is still there, but this time it's trapped inside the rocks. And well, this unfortunately doesn't help us at all. What I mean by this is that let's just say we hypothetically landed on Mars and wanted to get some of this water out of those rocks. We would have to bake those rocks for a very long time using a lot of energy, and it would be very difficult to recover even a tiny bit of water from those rocks. Going back to ringwoodite, for example, by weight only about 2% of the entire mineral here is water, and you need really high temperatures and pressures to basically try to extract the water from there. This here, for example, forms at about 2000 degrees Celsius and really high pressures inside planet Earth. And though maybe in the future there could be some techniques, for example using lasers or something really powerful to extract water from those rocks, right now there's really no efficient way to do any of this. The water there is really stuck for possibly forever. Without some sort of volcanic activity, without a lot of interaction inside the planet, trying to retrieve this water just like it's retrieved on Earth by the volcanoes is pretty much impossible right now. Nevertheless, this is an awesome discovery, and it also explains a lot of things that we observe on Mars, observe on planet Earth, and also maybe answers a few questions about Venus as well. But this is something we'll discuss in some of the future videos. So make sure to subscribe, share this with someone who loves learning about space and sciences, and if you love Mars, check out some of the new t-shirts that are going to make you feel wonderful that are also available in the description below. Also, maybe support the channel on Patreon or by joining the channel membership, because all of these things do help me quite a lot. Either way, hopefully you enjoyed this video, come back tomorrow, stay wonderful, and as always, bye bye.
Покажи най-добрата си страна с системата за бръснене Gillette Fusion. 5 изключително остри ножчета, монтирани върху подвижни пружини, които усещат и се адаптират към всяка извивка на лицето ти. Наслади се на прецизно и гладко бръснене, за да изглеждаш и да се чувстваш добре всеки ден. Gillette – най-доброто за един мъж.
A few billion years ago. But the question is, of course, how did this water disappear? And the new study that's 4%. This is Anton, and today we're going to be talking about new discoveries and a new study that suggests there's a new resolution to what may have happened to water on Mars. And this particular resolution relates to another video I made not so long ago that made some really incredible discoveries about waters of planet Earth. And in some sense, these two studies relate to one another, explaining both planets really well. But let's start one step at a time. Now, first of all, we know Mars definitely had water, simply based on the observations from various satellites that have found several different signs of ancient rivers and even signs of ancient tsunamis that most likely happened on the planet when some sort of an asteroid collided with one of the poles of Mars. We've actually talked about this in one of the older videos on the channel as well. And so the presence of ancient water on Mars is not really questioned by many. As a matter of fact, most scientists definitely agree that Mars had a very large ocean that covered a pretty large part of the planet, something that might have made it resemble this a few billion years ago. But the question is, of course, how did this water disappear, and what exactly happened to the planet to make this water all suddenly vanish over the past few billions of years? Now, the most common explanation today involves our sun and the lack of magnetosphere on the planet. Essentially, Mars lost its water, probably atmosphere as well, simply because the magnetosphere of the planet disappeared and was no longer able to protect the planet from the dangerous radiation from the sun, specifically various types of solar wind that can easily strip the planet of a lot of different particles on the surface. And because this has been measured many times, this is sort of a fact as well. But here's the thing though, was this the only process responsible for the loss of water on Mars? Or did something else happen? And how much water was there present to begin with? Which is actually where this study comes in and provides some really interesting and somewhat fascinating answers. With the main summary of the study being that it wasn't just the solar winds. A lot of water was also trapped inside Mars itself, very similar to how a lot of water got trapped inside our own planet. And a lot of water is still there today. But the way that it was trapped is kind of interesting. So first of all, we still don't really know exactly how much water Mars had approximately 4 billion years ago. There is, however, a lot of speculation that early Mars very likely looked like modern Earth. Although possibly also with a lot more ice cover on the surface and very likely with climates similar to what we have today in countries like Iceland. But once in a while this ice would melt and would create a global ocean as well. Today, however, all of the water is gone on the surface and only some water is still present at certain locations near the poles, with possibly some water being underground as well, with at least one lake previously discovered there. And so naturally the previous explanation using the sun as the culprit for the reason why Mars has no water made a lot of sense. And actually still makes a lot of sense, but the problem is we still don't really know how much of the ocean was present there, and we don't really know how much of the ocean was lost to the sun effects and how much of the ocean was lost to something else. But based on a lot of observations from the NASA mission known as MAVEN, the scientists over the past few years learned a lot about the interaction between the sun and the Martian atmosphere. Specifically here, they learned how the water vapor in the air of Mars is bombarded by various ultraviolet radiation from the sun, and how a lot of this interacts, eventually causing the hydrogen getting stripped from oxygen and essentially the water molecules breaking apart and escaping from the planet. Mostly because hydrogen inside water is a very light gas by itself, and so it's not going to stick around the planet and essentially escapes into outer space. But today we know that there is an isotope of hydrogen known as deuterium, and certain parts of water will contain this deuterium in there as well. Because deuterium is almost exactly double the mass of simple hydrogen, it's more likely to stick around and is more likely to actually remain on Mars, thus deposited in some sort of a rock or somewhere else where we can later find it. And because scientists today know the general ratio between hydrogen and deuterium in normal water, we can normally determine or estimate the presence of water on early Mars, or really anywhere else for that matter, using this technique. In other words, by comparing the number of deuterium to hydrogen atoms found in a certain sample, these scientists can usually estimate the total amount that was originally present in, for example, a certain sample somewhere else. And so by using various samples from various Martian asteroids, estimate the total amount that was originally present in, for example, a certain sample somewhere else. And so by using various samples from various Martian asteroids, and by examining the amount of deuterium compared to hydrogen in them, the scientists were able to estimate that the total amount of water must have been much larger, and the amount of water present versus the effects we're observing with missions like MAVEN are almost impossible to explain if only the sun was responsible for making Mars lose all of this water. It just doesn't lose enough water through the interactions with the sun. Something else must have happened to essentially have all of this water disappear somewhere. And the best explanation here comes from some of the younger samples that are less than 3 billion years old. For some reason in those samples, it's obvious the water has already disappeared, which suggests that the drying of Martian surface must have happened within about 2 billion years or so. It was a relatively quick event. And well, it just so happens that there is a pretty solid explanation coming from this other study about planet Earth, the minerals inside Mars, and specifically minerals tend to absorb more water as they cool down. We've briefly talked about this in the previous video when I discussed this mineral right here that's very prominent in the mantle of planet Earth, the mineral known as ring woodite. It just so happens that this thing right here is able to absorb a lot of water as it cools down. Or if we look at this from a perspective of a planet that was just born, as the early planet like Mars or even Earth cool down, and as the entire planet starts to slowly solidify and starts to produce all of these minerals, at some point a lot of these minerals will actually start slowly absorbing the water that's currently present on the surface. Okay, in this case it's actually a little bit too hot for water to exist. Here's a slightly more realistic scenario. So we have some liquid water here, and this water starts to slowly get absorbed by the minerals like ring woodite, mostly because they tend to increase their absorption value as they become cooler and cooler. They're basically like sponges in a sense. And all of this water slowly starts to combine with minerals and eventually gets deposited deeper and deeper into the ground itself. Now on Earth, because of plate tectonics, some of these minerals will eventually release the water through volcanic activity. But on planets like Mars and possibly even Venus, where we don't really think plate tectonics ever existed, well, on these planets, it's a lot more difficult for a planet to recirculate the water back into the atmosphere, and so a lot of it stays inside and slowly gets soaked into the planet itself, with a lot of water possibly disappearing as quickly as within about 500 million years, simply because Mars is a much smaller planet, so it also cools down much quicker than planet Earth. And so these minerals soaked in a huge amount of water, anywhere from 30% to up to about 99% as estimated in some of these studies. And this would hypothetically give Mars these early oceans that could be as deep as 5,000 feet or roughly around 1.5 kilometers. So essentially these huge oceans must have existed here, but slowly disappeared because of the way that the rock absorbs water. And because all of these hydrated minerals were mostly older rocks, with none of them being younger than about 3 billion years old, it means that Mars lost water really quickly. Also, of course, implying that Mars looked like this for possibly a pretty long time, possibly over 3 billion years actually. And the results from the study also resolve a lot of different mysteries, including the discrepancy between deuterium and hydrogen, including the calculations from the amount of water stripped from Mars today and the discrepancy between the expected amount and the amount observed, and also huge rivers and huge seas and oceans that used to be present on the surface, which would not really be possible if Mars had just a little bit of water like some of the early studies predicted. And the implication here is of course that a lot of this water, possibly most of the water on Mars, is still there. But this time it's trapped inside the rocks. And well, this unfortunately doesn't help us at all. What I mean by this is that let's just say we hypothetically landed on Mars and wanted to get some of this water out of those rocks. We would have to bake those rocks for a very long time using a lot of energy, and it would be very difficult to recover even a tiny bit of water from those rocks. Going back to rainwoodite, for example, by weight only about 2% of the entire mineral here is water, and you need really high temperatures and pressures to basically try to extract the water from there. This here, for example, forms at about 2000 degrees Celsius and really high pressures inside planet Earth. And though maybe in the future there could be some techniques, for example using lasers or something really powerful to extract water from those rocks, right now there's really no efficient way to do any of this. The water there is really stuck for possibly forever. Without some sort of volcanic activity, without a lot of interaction inside the planet, trying to retrieve this water just like it's retrieved on Earth by the volcanoes is pretty much impossible right now. Nevertheless, this is an awesome discovery, and it also explains a lot of things that we observe on Mars, observe on planet Earth, and also maybe answers a few questions about Venus as well. But this is something we'll discuss in some of the future videos. So make sure to subscribe, share this with someone who loves learning about space and sciences, and if you love Mars, check out some of the new t-shirts that are going to make you feel wonderful that are also available in the description below. Also, maybe support this channel on Patreon or by joining the channel membership, because all of these things do help me quite a lot. Either way, hopefully you enjoyed this video, come back tomorrow, stay wonderful, and as always, bye bye. Hello wonderful person, this is Anton, and today we're going to be talking about a new study that might give us a little bit more idea about how the early solar system was created, and more specifically, how many and what kind of supernova were responsible for, well, basically creating us as well. You might have heard this before that, we're all stardust, we're all made out of really ancient supernova that exploded a long time ago and basically spread their material across vast regions of space, with some of this material eventually creating our own planet, and some of that material later creating us as well. For example, this table of elements right here kind of shows you where a lot of the elements are from and how they were formed. Hydrogen and helium, along with some lithium, are the only things that were born in the beginning of the universe. A lot of the other stuff was created either through the explosion of stars or through some other major cataclysmic events. So for example, everything you see in gold, or in this color right here, that's basically very large, very massive stars undergoing type 2 supernova, sometimes also known as core collapse supernova. And that's when a massive star basically explodes and leaves behind some sort of a remnant, such as a neutron star or a black hole. And a lot of other elements, specifically stuff you see right here that's in grayish white color, that's exploding white dwarfs or type 1 supernova. Usually this happens when a white dwarf gets enough mass from its partner or possibly from another white dwarf that it collides with, and that usually results in a really large, really powerful explosion that often is used for a lot of scientific reasons as well, because it tends to produce the same amount of energy. These type 1a supernova were responsible for creating other elements. Here's actually what the typical nebula looks like after this explosion occurs. But there are actually several other sources of elements as well. For example, merging neutron stars, which brought a lot of gold and platinum, cosmic rays, which brought a lot of lithium, beryllium, and boron, and even some other unusual cataclysmic events, which might have brought even more materials. So trying to figure out where all of the stuff in, for example, our bodies came from has actually been always a curiosity for a lot of scientists. But in order to try to understand what happened in the beginning of the solar system and where the material came from, one of the major ways scientists usually do this is by using various meteorites and by then trying to find different ratios of different isotopes inside of those meteorites in order to establish certain age of certain particles. One of the reasons meteorites are preferred for this is because they actually didn't change much in the last few billions of years as they orbited around the solar system. Stuff here on Earth does change because of chemical reactions, but if you were to take a meteorite that stayed in outer space for 4 billion years, it's most likely going to be very similar to how it originally was when the solar system was just created. But first, very briefly about isotopes, with the example here being hydrogen. Normally, if you were to take an element such as hydrogen and expose this element to a lot of radiation, such as for example in a supernova, it will start acquiring extra neutrons on the inside, thus increasing its weight and creating what's known as isotopes. These isotopes are not stable though, and with time they will actually lose this extra neutron, eventually turning into something else. Now, one such famous example is based on uranium-lead dating, and it's when we take uranium-238 and try to measure the ratio between that uranium and another element known as lead-206. We know that after about 4.47 billion years, half of the uranium will actually turn into lead. This is a very well studied and well established fact, and though somewhat complex, kind of looks like this. There's basically this really long chain of elements turning from one to another until eventually, after this long series, it all ends up as the atom known as lead-206, and this one here is stable and will no longer change. Knowing this fact, we can actually use this to start measuring the age of different rocks. And that's basically how uranium dating works. Because we know that after about 4.47 billion years, half of this uranium become that particular lead particle, by measuring the ratio we can usually very accurately estimate the age of rocks. Which, by the way, was one of the isotopes used in this study. But naturally there are other isotopes we can use for even more precision, specifically ones that have much shorter half-life. And more specifically in this paper, they used one isotope that's now officially extinct. This one right here, known as niobium-92, which eventually ends up being the atom known as zirconium-92, which is the stable part of this chain. Now, the thing about niobium-92 is that it's only extinct because its half-life is only about 37 million years. But that type of a half-life is actually perfect to study certain events such as the creation of the solar system, and trying to actually investigate how things changed in the early solar system. But in order to make this work, the scientists obviously have to take several different isotopes from the same sample and then compare their ratios in order to create some sort of an accurate timeline of how things went and how things changed over time in that particular period. Because remember, we're currently right here, we're about 4.5 billion years after the creation of the solar system, and the scientists are interested in studying this right here, the birth of the solar system. And mostly because the scientists really want to find out what sort of supernova were responsible for adding a lot of different elements to the solar system. And so the scientists whose paper you can find in the description below were able to combine these isotopes and use the completely untouched by nature pristine sample of zircon that was actually discovered inside one of the meteorites known as Vestoids. The meteorite that originally came from the larger object known as Vesta, the protoplanet that never really became a planet. Now we know that these objects are pristine and, for the most part, are kind of untouched by anything, and because of this, samples from Vesta have always been kind of interesting for scientists studying the early solar system. And so by studying these particular rocks, they were able to establish how much of this extinct element of 92 niobium existed in the early solar system, thus allowing them to see how things changed early on and what kind of early events influenced the solar system when the planets were just created. And so by studying these particular rocks, the scientists were able to establish how much of that extinct niobium 92 existed in the early solar system, and thus how the solar system evolved and what sort of events, what sort of supernova influenced various parts of the solar system. And according to the scientists, because these minerals that they used in the study were basically pristine and untouched, they were the perfect opportunity to determine how much of that extinct niobium existed in the early solar system. And so by using these Vestoid meteorites, they were able to improve the so-called 9292 niobium zirconium chronometer, which then allowed them to date the early solar system much more accurately, which in theory would provide precise information about the formation of all of these early objects, including asteroids and early planetoids, in the early solar system. But for this particular study, what they discovered was essentially that the inner solar system, the part where Earth, Mars, Venus, and Mercury are located, were actually largely influenced by Type 1a supernova. And so that's of course the type when there's a white dwarf involved, and possibly another star where the white dwarf basically captures its mass, or another white dwarf that it collides with. So something like this happens in a relative vicinity of the solar system, approximately 4.5 billion years ago, and then delivered a lot of this material to the solar system, and a lot of this stuff basically made our planets. However, it's also possible that this is something that might have happened a long time ago, because a lot of these elements could have come from a completely different part of the galaxy. On the other hand, the outer part of the solar system, the part where Jupiter, Saturn, Neptune, Uranus, and a lot of other stuff is, were influenced by Type 2 supernova, and that's the core collapse supernova, when massive stars, very likely located not so far away from where the solar system was forming, basically collapsed, exploded, and created really large amounts of gas and a lot of different materials that essentially got enriched through the radiation from the supernova and then ended up in the outer regions of the solar system. Which of course totally makes sense, because if we were to look at other molecular clouds such as the Orion Nebula, where a lot of stars are being created right now as well, we know that a lot of this gas came from various supernovae in the past. And a lot of the stars that are currently really massive and are still located in this region are also going to explode and basically mix all of their material with the rest of the star systems forming there. Some of these star systems are probably going to become similar to the solar system, with a lot of this material eventually forming planets, comets, asteroids, and so on. And so in that sense, it's actually kind of interesting to see that the scientists for the most part figured out that there were at least 2 different types of supernova responsible for creating the planets and a lot of the other stuff in our own solar system. So once again, with the inner part representing the material that was created during some sort of a Type 1a supernova when a white dwarf exploded, and everything else, the outer part of the solar system, being represented by a Type 2 supernova, possibly even more than one. More importantly, at least one of these supernovae happened during a time when the solar system was being formed, which of course once again confirms that, well, we are star stuff after all. A lot of the heavy elements in our bodies, or basically everything that's not hydrogen, helium, and not lithium, very likely was created in these powerful explosions happening around the early solar system about 4.5 billion years ago. And this study establishes that it wasn't just one, it was at least 2, but very likely a lot more. But that's something that future studies will hopefully determine with a little bit more accuracy. For now, all we know is that a lot of exciting things happen in the solar system in the beginning, and it sounds like by seeing similar events happening in the regions like the Orion's belt, we can be pretty certain that a lot of very exciting star systems are going to be created in the future as well. And maybe at least one of them will also have some sort of an extraterrestrial intelligence, one day living there and exploring the life and the universe around it. But I guess for now, well, I guess all we can do is just wait for future studies that will actually determine the timeline with even more precision and more accuracy. For now, check out the paper in the description, subscribe if you still haven't, share this with someone who loves learning about space and sciences, maybe come back tomorrow to learn something else, and maybe support this channel on Patreon by joining the channel memberships or by buying the wonderful person t-shirt you can find in the description. Either way, I'll see you tomorrow, stay wonderful, and as always, bye bye. And this is Anton, and today we're going to be talking about some of the major discoveries from the last few months in regards to this beautiful planet that we actually still know so little about. But more specifically, we're going to be focusing on two major discoveries. One are the X-rays coming from this planet, and two are the studies in regards to the magnetosphere of this planet. And, well, let's start with the X-rays. With this beautiful picture right here, where the pink represents the X-rays, pretty much summarizing everything. Very recently, scientists studying the data from Uranus, the data collected over the years, actually over decades, by the beautiful Chandra X-ray Observatory, detected quite a lot of X-rays emanating from the surface of the planet and possibly even from the rings of this planet. And though it does sound unusual, it actually isn't, because Jupiter and Saturn also have been caught emitting X-rays in the past. But before we go on, well, let's start with the obvious, the rings. Yes, Uranus has rings, so does Neptune. So does Jupiter, and so does, obviously, Saturn. Even though generally we don't really think of Uranus as being a ring planet, it definitely is one, and you can even clearly see them right here in this simulation in Space Engine. But unlike the rings of Saturn, well, first of all, they're much smaller, but second of all, they contain different stuff on the inside. They're also extremely dark. Very, very dark. And that's why it's so difficult to see them. Both Neptune and Uranus seem to contain somewhat similar rings, and unlike Saturn's rings, the rings of Uranus and Neptune are really dark, and I'll explain to you why, because it does relate to some of the recent discoveries we're talking about today. But since unfortunately Voyager 2 is the only probe to ever visit this system and was only here for a very brief period of time, we still have a pretty limited knowledge of these rings, and most of the studies in regards to these rings and what happens around Uranus, for the most part, has since been done by various telescopes such as Hubble, and so there are still a lot of things we don't really understand. But back to X-rays. So as I mentioned previously, we've detected X-rays coming from Saturn as well, and also from Jupiter. But in this case, the scientists believe that for the most part, the X-rays are very likely just the reflections from the upper atmosphere of the solar X-rays, or the X-rays that originally came from the Sun and then got reflected by the atmosphere of Jupiter and Saturn. And so some of these detections were very likely also quite similar. Some of these X-rays detected in the last few years probably also came from the Sun. But the scientists believe that not all of them came from the Sun. As a matter of fact, there's also a very likely possibility that the rings are also responsible for creating some of these X-rays. And we know that this is exactly what happens around Saturn. In the past, when studying Saturn, the scientists also realized that a lot of these X-rays were really coming from the rings and not just from the planet. And it was pretty clear to the scientists that a lot of this X-ray glow was actually coming because the rings were actively interacting with the magnetic field of Saturn, and as various energetic particles collided with these rings, they essentially created X-rays that were visible from very far distances. And in case of Saturn, most of this X-ray production was done by the charged electrons as they interacted with oxygen atoms located inside the water icy rings, which then ended up producing this beautiful radiation you see right here. And so if it can happen around Saturn, it's quite possible that it might also happen around Neptune and Uranus as well. But there's another possible source for this X-ray radiation, and that's the aurora, the so-called northern and southern lights. Now originally the aurora on Uranus were detected once again by the Voyager probe, but they were also later seen by the Hubble telescope as well. And so we know that Uranus also has quite a lot of these aurora, or essentially these extremely powerful light shows, which do tend to produce X-rays as well. But the thing is, aurora on planets like Jupiter, and in this case Uranus, are not really produced in the same way as they're produced on Earth. The charged particles that produce aurora on Earth come from the Sun, but for Jupiter and Uranus, the charged particles actually come from the vicinity. They come from the interaction with the magnetic field, and very likely with a lot of other material, including the rings and the moons surrounding the area. And although today scientists generally understand how the Jupiter's aurora are made and have a pretty good explanation for what we're observing there as well, for Uranus, this is still a bit of a mystery. And mostly because the aurora and obviously the X-rays produced by the aurora directly depend on the magnetic field produced by the planet. And that's where we come to the second mystery and something that we don't really understand about both Uranus and Neptune. How is it that these two planets have such a strong magnetosphere, and what exactly generates it on the inside? So for example, we know that for Earth, the magnetosphere is most likely generated by the circulation of the liquid iron core, where the churning of the electrically charged material produces the magnetosphere that we have on the planet. For Jupiter and Saturn, something similar happens on the inside, except that it's not really iron this time, but it's metallic hydrogen. As you compress hydrogen and as it reaches a certain condition, it starts having metallic properties and acquires charge. And so the churning of a tremendous amount of hydrogen on the inside generates really powerful magnetic fields around Jupiter and Saturn. But Uranus and Neptune have something completely different going on, and that's where the mystery for the scientists begins. And first of all, well, here's a comparison. Here's the Earth's magnetosphere, with north and south being just a little bit misaligned with the rotation of the planet. But for Uranus and Neptune, not only is it misaligned in terms of their rotation, but it's also not really in the center of the planet either. On Uranus, the angle here is about 59 degrees, on Neptune it's about 47 degrees. And for both planets, the center is completely off as well. In this case, it's about 13,000 kilometers away from the physical center of the planet. Yet at the same time, both planets still have an extremely powerful magnetosphere, much stronger than the one on Earth, with Uranus having the magnetosphere that's about double the strength of the one on Neptune. But what's really strange here is that because of this unusual alignment, the magnetic field in the southern hemisphere of Uranus is much weaker than the strength in the north, and something similar happens on Neptune as well. It's actually about 5 times as strong on one side compared to the other. And because of this strange misalignment of the magnetic lines compared to some of the other planets, every single day on Uranus, the planet's magnetic lines align with the solar wind coming from the sun, and because of this, the planet opens up to a lot of the solar radiation, which basically means that this planet and all of its moons get bombarded by the solar radiation at least once a day. And if something like this was ever happening around planet Earth, well, it's very unlikely that the life would ever evolve here. But since both Neptune and Uranus have these very strangely aligned magnetic fields, today scientists believe that maybe this is just a common feature for many different ice giants. Ice giants being these distant gas giants that are usually smaller in mass than Jupiter and Saturn. But the other question here is, of course, so what creates this magnetosphere and why is it so strangely shifted? Now, this currently has no answer, but in the last few years, scientists have conducted several different studies, including this recent study from just a few days ago, where they tried to recreate the materials we might detect inside a typical ice giant, specifically highly pressurized ammonia and highly pressurized water, and possibly some other ices as well, with the main goal being a creation of what's known as the super ionic water or super ionic ammonia, or really super ionic ice. In this case, this is actually related to one of the videos I made previously about the discovery of a new type of ice that you can find somewhere right there. But in a nutshell, what the scientists are trying to make is basically water or ammonia under extreme pressures, and they're trying to see if it actually starts changing its properties. With the current belief being that if, for example, one of these super ionic liquids starts becoming more viscous and starts to flow much slower, it might actually explain why there is such an unusual magnetosphere inside these planets. If, for example, let's just say ionic water becomes either really viscous in certain conditions or flows really easily in other conditions, this would suddenly allow the scientists to explain why there is such an unusual misbalance when it comes to the magnetosphere of these planets. So basically, let's just say this ionic water becomes really viscous if you suddenly change just a little bit of its pressure. This means that it's going to flow really easily on one side of the planet, but become kind of like honey, very viscous on the other side, which would create larger chunks on one side compared to the other side, which would also shift the magnetosphere to possibly one direction. But that's of course just a theory, a science theory. Okay, that doesn't sound as good as game theory. Anyway, the point is that even today, including this study, the scientists haven't discovered such properties. They tried this with ammonia, and superionic ammonia does not become viscous enough to explain any of these observations. Which of course once again means that currently we have no idea how these magnetospheres of ice giants are created. So the explanation here still involves a lot of ionic liquids, so possibly water, methane, maybe ammonia, but it's not really clear why exactly is it that it's so one-sided, why is it shifted to a single direction. Now it probably does involve these exotic ices and their exotic properties of these ices that I've discussed in the previous video, but the details and the explanation is just not there. It's still a really big mystery. But it's a mystery that's kind of worth solving, because if this is what happens inside these ice giants, it means that many of these ice giants somewhere out there in other star systems will probably have something similar going on. And this could be even true of some of these smaller planets, including what we refer to as a super-Earth. If these ionic liquids can form on surfaces of these other planets, they will probably start experiencing some really similar magnetic effects, with magnetic fields being very misaligned and possibly behaving in a way that we don't really expect them to behave. But for now, this is not a mystery anyone has an answer to. Which once again means that, well, there needs to be a mission to these planets, a mission to Neptune, a mission to Uranus, and possibly even more missions to study their moons. A lot of mysteries here, a lot of really cool explanations for how magnetic fields are generated in ways that are different from planet Earth and from planets like Jupiter and Saturn, and also a lot of other mysteries that will definitely help us, well, learn a lot about the universe, but also probably develop some new technologies that we never really thought possible. And so the fact that no one is actually planning any major missions here yet is unfortunate. But hopefully a space agency somewhere out there decides to launch something sometime soon, and hopefully we'll actually get to explore these planets in the next few decades. For now, well, that's pretty much all I wanted to mention in this video. There's some X-rays we detected. We also think that magnetosphere might play a role in the creation of these X-rays, but how the magnetosphere is generated around them is a question nobody has an answer to. Once we learn more, I'll make sure to follow this up with another video. Until then, thank you for watching, subscribe if you still haven't, share this with someone who has learned about space and sciences, and maybe come back tomorrow to learn something you might have not known. Also, maybe support this channel on Patreon by joining the channel membership or by buying the wonderful Patreon t-shirt you can find in the description. Either way, stay wonderful, I'll see you tomorrow, and as always, bye bye. Hello wonderful person, this is Anton, and today we're going to be talking about some really interesting discoveries coming from the Hyades cluster, the nearest star cluster to us, because the recent research suggests something massive, something potentially groundbreaking, and something currently unknown disrupted the cluster millions of years ago, causing it to look somewhat different, with the main implication right now being that it might have been a very large chunk of dark matter. But let's talk about this a little bit more, because a lot of details here require some basic understanding of how all of this was discovered and what it might mean to science. First of all, the Hyades cluster is relatively easy to see in the night skies. Here is roughly where you would find it, and it sort of forms this interesting V-shape, with the telescope image of the cluster resembling something like this. But even though it doesn't actually look that big and it doesn't look like there are a lot of stars here, that's because the majority of stars are barely visible. They're just really small and don't produce enough light. They're still there though, and they have been discovered using some of the more recent observations. And so even in this simulation, if we increase the magnitude, suddenly this cluster looks a lot more massive and possessing a lot more stars. And a lot of these stars, including some of the other stars in the vicinity, have been very thoroughly observed and very thoroughly tracked by the incredible Gaia telescope from the European Space Agency. The telescope has already made so many different incredible discoveries in the last few years, and it still keeps making more and more. And using the data from this telescope, the scientists were able to discover something else that, well, nobody really found before. Now, the strength of this telescope is that it's able to track the precise motion and precise parameters of pretty much most of the nearby stars to us, and even some of the stars beyond. And so it has some really extremely precise observations of the vector of the motion of all of the stars in the cluster. And so based on this, the scientists were initially able to find some of the nearby stars belonging to the cluster that were not visible before. And they did so by essentially comparing the velocities of the cluster to the velocities of some of the nearby stars that might have left the cluster due to various gravitational interactions. In other words, even though initially some of these clusters might look like this, through various tidal interactions and gravitational interactions with things in the galaxy, they eventually start losing these stars, and a lot of these stars start going their own ways across the galaxy. But trying to find and trying to track these stars is a bit of a challenge. And so first, the scientists identified several hundred less visible stars in this region, confirming that they indeed belonged to the cluster in the past, which already means that a lot of these stars left the cluster and are no longer connected to it. But generally, just like with galaxies, as clusters interact gravitationally with the center of the galaxy or other objects nearby, they usually also start producing what's known as a tidal tail, two tails on both sides, one being the leading tail and one being the trailing tail. And so something similar is expected to be found here as well. And naturally, by looking around, the scientists started to identify that indeed there were other stars in the tail that were in the vicinity as well. And a lot of these stars only started to become obvious as Gaia discovered more and more stars with relatively similar vectors of motion, with this now representing over 1,000 light years of length. And so discovering these Hyades tails alone was already a pretty big achievement. But this wasn't the main achievement of the study, and this wasn't actually the most groundbreaking discovery here. And by the way, one of the reasons why the scientists were able to locate these stars is because they didn't limit their search to just some of the nearest objects. They decided to expand the search to some of the stars that might have left the cluster approximately 700 million years ago, which means that a lot of these stars would have a pretty different motion and orbits across the galaxy. But by using an astronomical software known as Amuse and by trying to combine it with various computer simulations, the scientists were able to build a predictive model of where other stars could be, the stars that came from this initial cluster about 700 million years ago, while also being able to create a kind of a simulation of the last 650 million years of the evolution of this cluster and how all of these stars spread across the galaxy. But then, by comparing the simulated stars with the actual observations from Gaia telescope, they did discover some really major discrepancies, specifically with the trailing tail. That trailing tail was slightly stretched and was missing stars where there should have been some stars, as if something extremely massive, specifically here about 10 million masses of the Sun, passed through this region and disrupted the orbits of these stars. In other words, the observations suggested some kind of a massive object disrupting all of this, creating a kind of an unusual asymmetry that's visible in the tails today. So even though it should really look like this, it seems that whatever passed through this region made it kind of look like this instead. And that something was a chunk of something really massive, about twice as massive as the central black hole. And so that's really where the mystery begins, because right now, well, on the one hand, we don't really know what it was. It definitely wasn't some sort of a black hole though, because it would have left a lot of other signs in its wake, but it still was something massive enough to pass through this matter and disrupt it just enough for us to notice. Oh, and by the way, something very similar was detected just a few years ago as well. There's at least one paper I discussed in one of the previous videos that talks about this in more detail. This was a discussion in regards to the detection of this unusual perturbation inside one of these stellar streams, which are these really large formations left by other galaxies around our own galaxy, and the perturbation suggested something that was just as massive passing through this region without any other signs. And so what exactly could it have been? Well, so far, the best possible explanation is the one that once again proves the existence and our speculations about dark matter. And in this case, this invisible cloud that we refer to as the dark matter halo that surrounds our galaxy and surrounds pretty much every other galaxy out there. And today a lot of scientists speculate that this dark matter halo that's around 1 million light years across is going to be made out of smaller chunks of what's known as a subhalos, nicely illustrated in this particular image as these relatively large chunks of something dark and something impossible to detect otherwise. But from what the scientists know or understand about dark matter, it doesn't seem to have any physical interaction with actual matter, only a gravitational interaction, so it can pass through a region such as a stream or a globular cluster and have no effect other than disturb the orbital parameters of stars nearby. And this beautiful simulation from Dennis Erkel, whose study you can find in the description as well, shows us roughly what the scientists believe might happen to these various clusters. So the red chunks here are dark matter. As you can see, they don't really interact with stars, but they do gravitationally change things. And this is probably what happened to this particular cluster as well. And so one of these subhalo overdensities, as they're known, passed through this region. It might have disrupted the globular cluster and changed the orbital parameters for some of these stars, which when simulated indeed recreates the actual picture that we see with the Gaia telescope. And so that particular collision with this massive 10 million masses of the Sun dark matter subhalo right now is the most plausible explanation, and once again is one of the best explanations for the existence of the mysterious massive dark matter. No other object that's massive enough is going to pass through this region without leaving some other unusual signs, such as, for example, huge amounts of energy released, or possibly even complete destruction of some of these stars. And so dark matter halo or dark matter subhalo, or basically a chunk of dark matter, right now is the best explanation. And since scientists have already seen other signs of this mysterious halo in other galaxies and have seen signs of potential mysterious massive dark matter through gravitational lensing effects, there is really little reason to doubt that this is what happened. But once again, we still need to be careful and we still need to analyze more data, do a lot more observations, and possibly find other solutions to this problem before this can be certainly stated as a fact. But it's still a really awesome discovery, and of course once again confirms that Gaia telescope right now is one of the most important telescopes out there, doing some really incredible research by analyzing and by studying billions and billions of stars and other bright objects around us. But when it comes to Hyades cluster, well, I guess in some sense it's just the beginning. Once other scientists join in and start analyzing these stars, we might even discover something completely different, something even more groundbreaking, more mind-blowing. And I'm going to make sure to talk about this in one of the future videos. So make sure to subscribe, share this with someone who loves learning about space and sciences. Maybe support this channel on Patreon or by joining the channel membership, or maybe by buying the Wonderful Person t-shirt you can find in the description. And stay wonderful, I'll see you tomorrow, and as always, bye bye. Hello wonderful person, this is Anton, and today we're going to be continuing our discussion about the Perseverance rover currently on Mars doing a lot of really interesting science. And in this video I wanted to give you some updates, including some of the recent pictures published by NASA, because officially the rover has already started scanning and analyzing different rocks, with the next step being the launch of the beautiful helicopter known as Ingenuity sometime in the next month or so, which by itself is going to be super exciting and also is going to be one of the bigger achievements of this mission. But let's start with some of the better pictures that NASA released in the last few weeks. And let's start right here with an aerial overview of where the rover landed in the location that's now referred to as the Octavia E. Butler landing site. And in the last few weeks, NASA was able to locate all of the parts, including the parachute, the descent stage, the heat shield, and show us exactly where they are now and where they landed.
Покажи най-добрата си страна с системата за бръснене Жилет Fusion. 5 изключително остри ножчета, монтирани върху подвижни пружини, които усещат и се адаптират към всяка извивка на лицето ти. Наслади се на прецизно и гладко бръснене, за да изглеждаш и да се чувстваш добре всеки ден. Жилет. Най-доброто за един мъж.
And in case you were wondering and wanted to see where the rover is in comparison to everything else, NASA's free application known as Eyes on the Solar System allows you to see exactly where the rover has landed and even takes you through some of the other missions here as well. And in the last few weeks, the rover has already started rolling around, having finished all of its major testing, and is thus now ready to start its journey across the Martian fields. Right now, NASA is planning to take this particular path you see on the screen, which will help the rover investigate several different ancient environments that according to NASA could have been once habitable. The rover is going to start at the cliffs defining the base of the delta produced by an ancient river, and the path will then take the rover up across the delta toward a possible ancient shoreline deposits. It's also going to attempt to climb up the 2,000 feet or 600-meter high rim of the crater and is then going to try to explore the surrounding plains. All of this should take approximately 1 Martian year or possibly about 2 Earth years. And just to give you a bit of a comparison here, the crater in the middle is roughly around 1 kilometer or about 0.6 miles in diameter. And as it's traveling around and as it's essentially crossing all of these locations, it's going to be using a device known as Planetary Instrument for X-ray Lithochemistry, also known as PIXL. And here's a device that allows PIXL to change the angle of the imager to get the best possible results from various rocks it's going to be scanning. And a lot of new images NASA has been releasing in the last few weeks look so much better than any previous mission. They look much crisper, they have a lot more color, and I was actually trying to figure out how they were able to achieve this, because normally in photography, at least for the color balance, you need to somehow set it up. And interestingly, on top of the rover, NASA engineers placed a few calibration targets with specific predefined colors and contrast that a lot of these cameras use to calibrate images and adjust for various changes such as brightness, in case, for example, a sudden dust storm or some other event occurs in the vicinity. There's even a website about this camera known as MastCamZ that tells us a little bit more about the details of the technique and also about the cameras used and how such incredibly high quality images are produced by the rover no matter what the light conditions are on the surface. And MastCamZ already allowed the rover to produce a very beautiful, very high quality 360-degree panorama shot that's over 200 megabytes in size, and you can actually go and download this yourself, which will allow you to see the surrounding area in extremely high detail. It was produced by taking individual shots and combining all of them into one large mosaic. And here you can kind of even see how the rover was able to produce all of this by essentially adding up every individual picture one after another. This allowed it to create an extremely accurate and very rich in color shot of the surrounding area, which allowed the NASA scientists to first of all plan the pathway that the rover will be taking in the next few weeks, but also allow the scientists to identify certain interesting features on the ground, such as certain rocks they would like to take a look at, which the scientists have already started to explore in the last few days. Here's one of many rocks that NASA identified. This one here is a wind carved rock that's only about 2 feet in diameter, something that tells us about how inhospitable and how extremely windy conditions on Mars can get once the dust storms begin. There's also this really interesting shot of what seems to be a fan-shaped deposit, and this is very likely a sediment of what's known as a delta or river delta. This is very likely where an ancient river was entering into an ancient lake inside the Jezero crater on Mars. And this is also the location where the rover is planning to go in the future. Now, NASA also released this interesting video showing us the virtual visualization of the first attempt to move the rover, and this basically shows us the first steps of Perseverance on Mars, with the actual tracks visible afterwards as well. And following the initial analysis of the panorama picture, NASA scientists decided that there are 2 possible paths the rover can take in the next few weeks. In this picture you can see them in blue and in purple. But eventually the rover is going to end up very close to the delta I showed you previously, and it's going to start heading there sometime in the next few weeks. And because the rover has 23 different cameras on board, it's going to be able to take a lot of different imagery throughout its travel. As a matter of fact, every single day NASA has been posting anywhere from a few dozen to several hundred pictures, all of which are available in the link you can find in the description below. And though some of the cameras like the nav cams are going to produce better quality images, some of the other cameras like the HAZ cams or hazard cameras are also going to be very useful in finding things that other cameras cannot see. But on the way to the delta, the mission is going to essentially stop at pretty much every rock like you see right here that was done recently, and it's going to use its pixel camera to try to analyze various rocks for composition in order to discover the history of Mars and also possible signs of previous life here. The way this is done is by taking different views of the same rock, which will usually produce something like this. This is an example of another rock the NASA scientists currently refer to as Ma'az, which in Navajo language means Mars. And then by analyzing this with a camera such as the SuperCam, the scientists can determine the origin and other features of these rocks. In this case, this particular rock has been discovered to be basaltic in composition, and it's also most likely a volcanic rock in origin, consisting of different fine grains of igneous material that was cemented over time in some sort of a watery environment, once again showing us that the water was flowing through this region. But the most exciting part in the next few weeks is going to be the Ingenuity Mars helicopter. Only a few days ago, the protective cover or the debris shield was released from the rover. This was protecting the helicopter during the landing. And now the helicopter is going to try to rotate down and assume a position necessary for a vertical takeoff. The Ingenuity helicopter is going to attempt its test flight sometime in the next 30 days. And the engineers have already added different locations and different parameters for this test flight, including the so-called airfield, or the area where the helicopter is going to be flying, along with the potential flight zone, all of which will be documented by one of the cameras known as HiRISE on top of Perseverance rover. Here's actually another look of all of this from a different perspective, and this is exactly where the Perseverance rover is going to be in order to observe all of this. And for the Ingenuity helicopter, this is what it sort of will look like, with an overlay roughly showing us where the helicopter is going to be flying. And the brief profile of the mission is, well, essentially as follows. It's going to take off, it's going to fly around, take a few pictures, and then either land in the same location as before or potentially in a new site, assuming that it finds a flat enough site somewhere in the area.
Head & Shoulders представя първия душ гел и шампуан 3 в 1. Коса, лице и тяло. Пробвай Deep Cleanse с въглени мента, Sensitive с алоe или спорт с екстракт от сандалово дърво. Избери точния за теб.
And on top of this, NASA has also released several audio files, allowing us to hear what it sounds like for a rover to, well, basically rove around Mars. It doesn't really sound that super exciting, so I'm not going to be playing it in this video, but you can check out the link for this in the description below. And on top of this, one of the links in the description allows you to explore some of the recent images, like this one right here from yesterday, showing us what seems to be a rock, and you're going to be seeing a lot of rocks in those pictures, which to me at least looks extremely similar to the meteorite rock picture that was taken by one of the previous missions a few years ago. But this is definitely where the exciting part for the geologists comes in, because they get to analyze these rocks by looking at them and by getting the data from the previously mentioned X-ray camera, and then compare them to similar rocks we've discovered on planet Earth. Now, if you'd like to learn a little bit more about Martian rocks versus Earth rocks, I'm also posting another really cool geology post that goes through this in a lot of detail. But I guess for now that's all I wanted to mention in this particular video. We're going to be hearing more about Perseverance rover and Ingenuity helicopter in the next few weeks, and I'm definitely going to be following this up with another video when the helicopter takes flight and when we get the details of the flight itself. For now though, check out some of the images NASA posted from their website, and check out some of the other images I posted in the description below as well. Also subscribe, share this with someone who loves learning about space and sciences, maybe come back tomorrow to learn something else, and maybe support this channel on Patreon by buying the Wonderful Person t-shirt or by joining the channel memberships as well. Either way, thank you for watching, I'll see you tomorrow, stay wonderful, and as always, bye bye.
Head & Shoulders представя първия душ гел и шампуан 3 в 1. Коса, лице и тяло. Пробвай Deep Cleanse с въглени мента, Sensitive с алоe или Спорт с екстракт от сандалово дърво. Избери точния за теб.
Hello wonderful person, this is Anton, and today we're going to talk about how lightning might have had a very important structure or trying to figure out. Hello wonderful person, this is Anton, and today we're going to talk about how lightning might have had a very important role in helping life start on early Earth, and also discuss the idea of how lightning changes the chemical composition of a planet over millions and billions of years. But to start, we have to go back in time about 4.5 to 3.5 billion years ago. It was a lot more inhospitable to life and looked extremely different from anything we have on the surface today. But then within only a few million years, it most likely also started to acquire a lot of water on the surface, and at some point might have even turned from this into some sort of a wonderful water world, with very likely no surface showing whatsoever. But then sometime around 3.7 to maybe about 4 billion years ago, first life started to appear on the planet and continuously evolved for billions of years afterwards. But in order to form all of this early life, a lot of very specific elements had to be present on the surface, and we're still trying to figure out how some of these elements made it to the surface. Although the assumption today is that most of this material was probably brought to Earth through various collisions for billions and billions of years. Now this makes a lot of sense for most materials, but some elements are still very difficult to explain if it was really only asteroid collisions. Especially because about 3.5 to 3.7 billion years ago, when life began on Earth, generally speaking there weren't really that many collisions compared to, for example, the late heavy bombardment, which occurred a few hundred million years prior to this. And there's one specific element that the scientists are particularly curious about, or at least where it really came from, and that's the element known as phosphorus. The origins of element phosphorus are extremely important to understand because pretty much everything related to life on Earth uses phosphorus to some extent. For example, phosphorus plays an extremely important role in the structure of both RNA and DNA molecules, essentially representing the structure or the structural framework of the molecule itself, while at the same time pretty much most of the energy inside our cells uses what's known as ATP, or adenosine triphosphate, which is in some sense often referred to in biology as the molecular basic unit of energy transfer. And the P in ATP stands for phosphorus, so it does play a really important role in the formation of this particular molecule. Not to mention that phosphorylation reaction itself is an extremely important reaction in biology, and even if you were to look at the structure of the cell itself, the cell wall is made of what's known as the phospholipid. And the phospho in the phospholipid is once again phosphorus. And so in that sense, no matter where you look in our bodies or really any part of the body of any living being on the planet, you'll always find some need for phosphorus. And even our bodies, human bodies, contain about 700 grams of phosphorus in them, with the vast majority being inside our bones, about 85 to 90%. But the question is, of course, where did it come from originally? How was it created on early planet in order to be integrated into the life we have today? Now, all of the early explanations did involve asteroids, but as I mentioned previously, this explanation is not really that satisfactory. As a matter of fact, there is a slight discrepancy between how much phosphorus we expect on the planet to be delivered from asteroids and the actual amount we find on the surface. So there might have been something else going on here, especially because early Earth was definitely very different from the modern Earth. And so the scientists whose paper you can find in the description below propose a pretty brilliant explanation, and an explanation that actually makes a lot of sense. They believe that it was made by lightning, a lot of lightning strikes on the early planet. And we're not just talking about million or even billion lightning strikes, we're talking about quintillion lightning strikes that occurred in the first billion years or so. And back then there were a lot more lightning strikes than we have today, and today we still have quite a lot. There's approximately 500 million lightning strikes per year. And this map from NASA kind of shows you the frequency map of the average lightning flashes on the planet, with a lot of lightning strikes being concentrated in the more tropical areas. There are actually so many lightning strikes that they even produce a kind of an electric hum in the atmosphere of our planet known as the Schumann resonance. We will talk about this in one of the future videos, so make sure to subscribe because that video is coming in the future. But the estimates suggest that early Earth might have experienced up to about 5 billion lightning strikes, with at least 1 billion hitting the planet's surface. And it is actually a really cool example we have from the planet today of what happens to the surface of the planet when the lightning strikes hits. What you're looking at right here is known as a fulgurite, and this is what happens when the lightning hits the surface of the Earth. Fulgurites are a pretty well-known phenomenon, and there's actually quite a lot of them all over the place, and normally they kind of look like these tubes you see on the right. And so in a nutshell, this is actually a type of glass that's produced in extremely high voltage environments. And depending on where the lightning strikes, like for example in this case this was a sand fulgurite, they will contain different materials on the inside, but their shape is generally going to be like this long tube because of the actual shape of the lightning. And generally speaking, today the scientists know that some of the useful phosphorus on the planet was originally delivered to the planet by various meteorites that could have been rich in phosphorus, like this one right here, with the material on the inside known as schreibersite. This contains a lot of metal, but it also contains phosphorus, and if heated enough, especially during a collision with planet Earth, some of this phosphorus could be released and become useful for life development. However, the scientists in the study discovered that similar material can also be produced when a lightning strikes certain types of clays. And so in this case, imagine an early Earth environment where there is a lot of clay near some sort of a lake or an ancient ocean. A sudden lightning strike of this location will create enough conditions here to suddenly change all of this phosphorus on the inside, making it more useful for life. As a matter of fact, it might even create some other components that are necessary for life. With all of this material then getting released and combining with other stuff to create a lot of bioavailable phosphorus. And possibly also a lot of other compounds, thus creating the conditions necessary for early life to start developing. And if a lot of these lightning strikes started to hit the part of the planet where there was a lot of clay very close to the water, all of this would create perfect conditions for life to suddenly begin and to start evolving. There will be a tremendous amount of new materials for life to use and to start developing RNA, DNA, and of course all of the other structures that today use phosphorus to some extent. Now, because this is just the first paper, obviously more investigations and more analysis is needed, but if the authors of this paper are correct, it means that we might have a new signal and something else to look for out there if we're trying to find life somewhere else in the universe. In this case, we need to look for planets that either had or have a lot of lightning on the surface. Because according to this paper, lightning is essential to the creation of life, at least early life, and to the formation of certain molecules that would be otherwise very difficult to form. And because eventually with better telescopes, we should be able to observe both the presence of phosphorus and of course the presence of lightning strikes, it might even help us discover life somewhere out there by just using this particular technique. And since according to the scientists in this paper, anywhere from 100 kilograms to possibly even 10 tons of phosphorus and other compounds similar to phosphorus could be produced by lightning strikes every single year on one of these planets, it means that over millions and billions of years, a tremendous amount of different compounds is produced in this way. And so if we do find planets with a lot of lightning strikes on them, and if those planets also exhibit signs of phosphorus in the atmosphere, we might actually have a really good chance to find some sort of life on those planets. But I guess for now that's kind of all we know. Until we learn more or until other papers come out describing what else lightning does to the surface of the planet, that's pretty much all I wanted to mention. Check out the paper in the description, subscribe if you still haven't, share this with someone who loves learning about space and sciences, maybe come back tomorrow to learn something else, and maybe support this channel on Patreon by joining the channel membership or by buying the Wonderful Person t-shirt you can find in the description. I'll see you tomorrow, stay wonderful, and as always, bye bye. In our search for solutions to the mysteries of the universe, and in our search for various incredible objects out there, the scientists have developed a lot of different techniques, and some of these techniques are really mind-blowing. Hello wonderful person, this is Anton, and today we're going to be talking about another really awesome discovery, and in this case of what the scientists refer to as the Goldilocks black hole. Black hole that's not too big, not too small, just perfect. The black hole that we've been looking for a very long time, the intermediate mass black hole. And in this case, they actually used a brilliant analysis and a brilliant technique to discover all of this. Now, first of all, let's start with the technique itself, which is based on this very beautiful phenomenon known as gravitational lensing, the effect that's predicted by the Einstein's theories and that we kind of see all over the universe. And this effect is produced when a somewhat bright object sends its light toward us, and this light goes through a region where there's a lot of mass, such as a galaxy, such as mysterious dark matter, or possibly some kind of a black hole. And this is what we usually see from
They say the legends of the past are meant to teach and warn
Earth. And this usually works for a lot of different objects, such as supernova, quasars, or a lot of other objects that are bright enough to emit their light for a very long distance. But there still has to be something massive right here in order to cause the light coming from these objects to bend and to form these beautiful images, such as this image from Hubble telescope known as the Einstein ring. And the thing is, we usually can figure out exactly what we're looking at by reconstructing the ring, but also calculate the precise mass of the object in front that caused the light to be bent and that caused the gravitational lensing to occur. And so in the last few decades, scientists have learned how to calculate all of this quite precisely. But most of the other studies usually use either bright quasars because they're relatively easy to see, or in some cases supernova, and in some other cases some other bright objects, but not really what's known as gamma ray bursts. Gamma ray bursts are known as the most powerful, most energetic events in the universe, and we generally think that they form, well, this video from NASA is about to show you. It's essentially when a tremendous amount of energy is released from a core of a massive star that runs out of its nuclear energy, and as it collapses under its own weight and is about to form a black hole, this black hole ends up driving this really large jet of particles out of this region, and all of this starts to move through various particles that have already been deposited there previously. This jet, as it collides with these particles, ends up producing a tremendous amount of energy, and this is usually in gamma ray radiation because of the powers involved here. And so basically, because the jet is so powerful and moves so fast and slams into all of this dust really fast, it ends up releasing these gamma ray bursts. And all of this happens really quickly too, although in some cases it does actually have a slightly longer effect depending on the original star and also depending on how much dust was in the region. And so it can be anywhere from just a few milliseconds up to a few hours in length. Also, generally these events are believed to only form in some of the most powerful supernova, also known as superluminous supernova, so a typical supernova might not necessarily produce these. While others can also be hypothetically produced when two neutron stars collide, creating something very similar to what you just saw from a typical supernova explosion. So these events do have slightly different origins, but generally we know the overall structure of how these events progress and what to expect when we detect the first few milliseconds of this event. And so as an example, this image from NASA shows you the overall position in the night skies of pretty much all of the gamma ray bursts that were detected by the mission known as BATSI mission. And after about 8 years of observations, approximately 2,500 of these bursts were detected across the night skies. And so there's definitely a lot of gamma ray burst data already available to us from as far back as a few decades ago. And because of this, you can actually use this data to study various other effects. And this is exactly what the scientists in this particular paper, that you can find in the description below, decided to do. They essentially reasoned that somewhere in this gamma ray burst data, they can hypothetically discover one of these gamma ray bursts that might have been also gravitationally lensed by something really massive as it passed through some sort of a region as it moved closer and closer to Earth. And specifically, they were reasoning that they can discover this by looking at the gravitational lensing echo. And the way this echo forms is explained in this video from Leiden Institute of Physics. Notice how when the actual position of the object is not really in the middle, one of the lines is going to be slightly longer than the other. And that means that the light from this bright object in the back is going to arrive at different times, which means that there's going to be a kind of an echo in the data, as if the same gamma ray burst happened twice. And if we actually find this in some of the data, it means that it must have been gravitationally lensed by an object, a massive object, that was slightly misaligned. And to analyze all of this, the scientist behind the study developed his own library for Python.
So, how was Turkey?
Which he refers to as PyGRB, Python Gamma Ray Burst, analysis tool. And this particular analysis tool is specifically developed to be able to find these echoes and a lot of other unusual data from various gamma rays that have been detected over the past few decades. And as you can probably imagine, they did discover one such burst that did have an unusual echo in it. An echo that was caused by something really massive, approximately 55,000 masses of the Sun. And just to give you a comparison with some of the other black holes, here's what a typical smaller black hole looks like. This is the type that we usually detect when black holes collide, or some of the other black holes we detected in our own galaxy. Just to give you a comparison, this right here is Phobos, one of the moons of Mars. So this is an object that's maybe about 30 kilometers across or so, but the size here doesn't really matter much because it's all about the mass. And the mass here is roughly around 10 masses of the Sun. Then a lot of other black holes we've discovered are supermassive black holes. The one in the middle of our own galaxy, Sagittarius A star, roughly about 4.3 million masses of the Sun, and several times larger than our own Sun in terms of size. But unfortunately, in between these two sizes, there haven't really been too many discoveries. These so-called intermediate mass black holes have been a mystery. And so far we've only discovered a couple of other intermediate mass black holes, with one not so long ago that in terms of mass was about 300 masses of the Sun. But we've never found a black hole that was thousands of masses of the Sun. We've never found this Goldilocks black hole, something that fits right between these two. Something that would explain how these massive black holes form, because naturally if we find an intermediate mass black hole, we can then explain how more massive black holes form. But without seeing these intermediate mass black holes, it's extremely difficult to explain how any of this works. But by discovering this unusual gravitational lensing effect coming from a gamma ray burst known as GRB 950830 that was originally discovered back in 1995, the scientists were pretty certain that whatever it was first of all really massive, 55,000 masses of the Sun, but second of all was very compact, and compact enough to be very likely a black hole. And in this graph itself you can even see the original detection and the echo that followed. And although hypothetically this could maybe also be some sort of a massive globular cluster with just a lot of mass concentrated in the center, the data does suggest that the object is just a little bit too compact, a little bit too dense to be that. It is more likely to be a very massive, almost point-like object, which in this case would only suggest a black hole, and more specifically an intermediate mass black hole, something that the scientists have always tried to find and something that so far we kind of failed to find. Or at least intermediate mass black holes with masses in thousands of masses of the Sun. All of the previous detections never had a mass over 300 masses of the Sun. And at the moment, this seems to be the first ever statistical confirmation of the existence of these types of black holes and the first confirmation of a gravitationally lensed gamma ray burst. Something that scientists suspected they're going to find at some point, but something that has so far not been discovered until now. And by the way, in case you were wondering how they actually know how compact this object was, and if you're like me and you're sometimes too lazy to just go through the data yourself, it's really due to this, the actual delay. The delay here is in milliseconds, and this can only be done by an object that's extremely compact. If the object was much more widespread, the echo would arrive much later. But because the echo arrived so quickly after the initial detection, that's why it was first of all missed originally, mostly because back then we just didn't have the technology to analyze all of this in such a detail. But second of all, it just means that the object was really small in size. Not in mass though, but in size. With the total size of this object roughly being equivalent to maybe about twice the size of planet Jupiter. So it is very compact, and we don't really know of any other objects that can be so small and have such a huge mass. So for now at least, this right here is the best explanation. But by detecting this object, we now have a pretty good idea and a pretty good explanation for how larger black holes could be created as well. Assuming of course all of this is confirmed and maybe some of the other IMBH or intermediate mass black holes are discovered somewhere out there, all of this would then provide a really good explanation for how these black holes can easily grow over time to masses of millions and even billions masses of the Sun. Obviously, if a lot of these black holes start colliding with one another for millions and billions of years, some of these black holes might actually end up really large. And so by using the technique developed in the study, a lot of other scientists might end up discovering even more of these massive compact objects, and for all we know, possibly even discover some other mysteries we can't even imagine right now. But I guess until we discover more, or until more data is available, that's pretty much all I wanted to mention in this video. A pretty cool discovery, a really great analysis, and definitely something to look forward to once more scientists analyze, reanalyze, and possibly discover something else. Until then, thank you for watching, subscribe if you haven't, share this with someone who loves learning about space and sciences, maybe come back tomorrow to learn something else, and maybe support this channel on Patreon by joining the channel membership or by buying the Wonderful Person t-shirt you can find in the description. Either way, I'll see you tomorrow, stay wonderful, and as always, bye bye.
По-добрия Великден за цялото семейство. Електрическата четка Oral-B премахва повече плака и има режим за чувствителни зъби и венци. Подари здрави усмивки. Go Oral-B Electric.
Hello wonderful person, this is Anton, and today we're going to be talking about a new discovery coming from, of all places, Antarctica, where the scientists have recently identified an event that we usually refer to as a super bolide, an extremely powerful explosion because of a meteor that explodes in the upper atmosphere, creating an explosion that is sometimes equivalent to several nuclear bombs. With the most famous such event being the Tunguska event that happened back in 1908 and created such a large explosion that it destroyed millions of trees, leaving a tremendous amount of damage in the process. The event that I've discussed in a lot of detail in one of the previous videos that is going to be popping up somewhere above my head at some point. But now the scientists have identified signs of a super bolide happening in Antarctica, although it was quite a while ago, specifically about 430,000 years ago. But it was more powerful, and more importantly, it left a lot of clues around Antarctica. But despite all of this study that you can find in the description below is still extremely important in order for us to learn several things about these events, mostly because we now understand that they're really common, we just don't always get to see them. For example, you might have heard about the 2013 Chelyabinsk event, the event that was filmed from many different dash cams in different cars in Russia, and essentially surprised everyone. It came out of nowhere, it created a huge explosion, it also caused quite a lot of damage, luckily no one died though, and at the same time it allowed the scientists to study these events because they turn out to be very common. What you might have not heard of though is another really similar but even more powerful event that happened in 2018. The event known as the Kamchatka Superbolide that more likely, despite the smaller size, having produced even more energy and more destruction. But it just so happens that it happened where there was no one to witness it. Actually, there was only one witness, the very famous satellite known as Himawari 8, famous in Japan that is, mostly because it provides really beautiful images of planet Earth from that part of the planet, and also I personally have used it many times to keep track of various dust particles, especially when a lot of dust comes from China, which usually happens every year. This satellite produces some of the most beautiful imagery I've seen from any weather satellite on the planet, and it's actually really useful for a lot of different studies. But in 2018, completely by accident, the satellite recorded this, a relatively large and relatively powerful explosion of what seemed to be another bolide, or in this case a superbolide. And this explosion, just like the one in Chelyabinsk, and just like the one in Tunguska, was responsible for producing an explosion that was very likely at least a few Hiroshima bombs in power. And some of you might already know from some of the previous videos, NASA keeps a really good track of all of the bolides happening around the planet. And so according to NASA, here's the list, the total list of all of the bolides that happened around the planet since 1988, with the largest one being the one in Chelyabinsk and the second largest one being the one in Kamchatka. But also several other really large explosions, which you see in yellow and in orange, that might have gone unnoticed, specifically the ones over the ocean, the ones in Antarctica, or in some other remote locations where there are just not a lot of dash cams or CCTVs to witness the event. There are almost 900 events in this list, and a lot of them, for the most part, have enough destructive power to, well, ruin someone's day at least, but usually cause some damage to a typical city. Luckily for us though, only one of them happened over a major city, Chelyabinsk. But because this is all statistically distributed, at some point, somewhere in the world, some of these rocks are going to explode over a populated town. Something that has happened in history back in 15th century in China, which did cause a tremendous amount of damage and a tremendous loss of life. But that's something we'll talk about in one of the future videos.
They say the legends of the past are meant to teach and warn the generations to come. Let me tell you my favorite story. Once upon a time, in a faraway land, ruled the great King Corvus. Mighty, wise, and kind, he was the true patriarch of his nation and a loving father to his only daughter, Princess Morrigan. The father's duty is to protect the family. When the kingdom was struck by a dreadful enemy, Corvus could not let himself hide behind the castle walls. He faced evil in the decisive battle, fighting side by side with his mightiest warriors. His army was victorious, but the price was horrible. The father had raised his daughter well. Morrigan, too, was ready to sacrifice everything for the family. Heartbroken, she locked herself away in the royal library, hoping to find a way to deal with the death itself. The candle.
And so by learning more about these events and trying to understand their frequency and the most likely origin of these rocks in order for us to find more of them, we might be able to one day predict them and thus have a possible chance of stopping these explosions from happening over a major populated city. But what exactly happened in Antarctica 430,000 years ago? Now, first of all, the scientists are convinced that this event was more powerful than the Tunguska event, which we believe happens maybe every century or so. Tunguska was at least 3 megatons of explosive power, overall equivalent to a relatively large nuclear bomb, and this ended up destroying roughly around 2,000 square kilometers or about 830 square miles of the surface around where the explosion occurred. And so the event in Antarctica was more likely more powerful than that. And though it's not entirely well understood yet what exactly happens to these rocks when they enter the atmosphere, most of the suggestions scientists have so far are related to the idea of air suddenly rushing into the rock itself and causing it to explode dramatically. NASA actually made this beautiful simulation that you can find in the description below that sort of shows us what happens inside these rocks as they suddenly enter really highly pressurized area such as our own atmosphere. And this is sort of what the simulation show us happens inside these bolides. Now, most of these rocks almost never really make it to the planet. This is why we call them meteors. And at the same time, all of these leftovers then end up circulating the planet, creating various emissions on the planet. As a matter of fact, this orange glow you see right here, something that can be easily seen in images from the International Space Station, is what's known as the sodium layer. The sodium layer here is formed by various meteors and of course bolides, burning up in the upper atmosphere and leaving behind a lot of sodium, which then sort of creates this light that's formed by the sunlight. With the main difference being that the larger the rock is, the more likely it's going to cause an extremely explosive event, something that the scientists are still trying to understand a little bit better. So for example, the size difference here is really not that much, with the speed difference also being not very high, but one of these events was about 3 times as powerful as the other event, with Tunguska event being even more powerful, even though the size difference here is once again not really that high. And following this initial explosion and the release of the material here, it then starts to circulate around the planet, as you'll see in the simulation from NASA, which is something that different satellites detected afterwards as they orbited around the planet. So here you can kind of see that all of the debris here eventually starts moving around the planet and is then detected by various satellites and a lot of other detectors on the planet. And so if a bolide is large enough, it can potentially even cause certain changes in the climate and possibly even lower the temperature of the planet for some time. And so this is something that does affect our planet quite dramatically. But obviously the Chelyabinsk meteor was not very big, so the effects were very minute. But the one in Antarctica, when it exploded, it very likely created a much larger explosion, also melting some of the ice underneath, and at the same time created such a huge shower of explosive matter that over the years scientists were able to recover several different samples from pretty much the entire Antarctica, with several different areas, 4 areas specifically, shown on this map right here. And the recent research was done in this particular spot, where several of these tiny particles, which are usually produced during bolide events, something that the scientists often refer to as the chondritic spherules, or essentially leftovers from really large asteroid explosions. And by scanning these particles, they discovered that they contain a lot of iron, a lot of olivine, and also a lot of nickel, the usual culprits we find inside a typical asteroid or a typical rock coming from space, with the composition roughly matching the type of meteorites known as pallasites, one of which you see right here in this image. But more importantly, the scientists were then able to chemically match the samples they discovered in their location to some of the other samples from other studies, thus implying that all of these particles found in 4 different locations were very likely produced in a single event of a really explosive nature. And since the scientists so far have not discovered any crater anywhere in Antarctica, the implication here is that the rock most likely exploded in the atmosphere like a typical bolide, thus leaving behind nothing. Nothing but these tiny particles that were then discovered in different locations. And so by discovering this event, the scientists can now start estimating the likelihood of similar events happening sometime in the future. As a matter of fact, the more of these bolide events we discover on the planet, the more likely we'll be able to find some kind of a statistical prediction model which will allow us to at least know when the next one will happen. Because for now at least, these events right here are definitely the ones we're having the most trouble predicting, tracking, or in some sense knowing what to do with them even if we discover that one of these events is about to happen. We don't really have any means of redirecting these asteroids, nor do we have any means of preventing them from hitting the planet. As a matter of fact, so far there has only been one event that was predicted only a few days before it happened, which was then tracked for a few hours. But that was a complete accident, and so far no good model exists in helping us anticipate, predict, or prevent air bolides from striking again. And so these types of studies are pretty essential in helping us understand how frequent these events happen, where they might come from, or more importantly, what to do about them if we know one is about to occur. Because as of right now, we seem to only know about these events after they happen. Right now, this is all just pure probability, pure game of chance. So definitely an important study and definitely something you need to be aware of, especially as more and more people start living in large cities, and more cities could potentially become the next target for one of these events. Something that already happened in Chelyabinsk, something that happened in China in the 15th century, and something that might or probably will happen in the future as well. So that's something we'll discuss more in some of the future videos, and well, until then, check out the study in the description below, all of the relevant links there as well, and subscribe if you still haven't, share this with someone who loves learning about space and sciences, maybe come back tomorrow to learn something else, and maybe support this channel on Patreon by joining the channel membership or by buying the Wonderful Person t-shirt you can find in the description. Either way, I'll see you tomorrow, stay wonderful, and as always, bye bye. Hello wonderful person, this is Anton, and in this video we're going to be talking about this unresolved mystery coming from the center of our own galaxy. The mystery of this strange glow that the scientists detected back in 2009 that still doesn't actually have a good explanation, but that some of the recent studies decided to investigate in a little bit more detail, trying to discover what it could be and also what it couldn't be. In the process also providing enough evidence suggesting that this could technically be dark matter after all. Now, originally this unusual glow was discovered back in 2009 when the scientists using Fermi telescope, and this was when the Fermi telescope just started operating, decided to subtract all of the other possible glow visible here and try to see if they can discover something else unusual. And they found that even by removing pretty much most of the other light coming from the center, there was still this unusual excess of gamma ray radiation, and they refer to this as the galactic center gamma ray excess, or also known as galactic center giga-electron volt excess. But nobody really knew exactly what it was, and Fermi telescope also started making a lot of other discoveries, so this wasn't really a priority anymore. With the biggest discovery of course being the Fermi bubbles, named after the telescope. But this didn't change the fact that there was still no good explanation to what exactly this was in the middle of the galaxy, producing approximately 2% more gamma radiation than should be produced coming from this region. So in other words, the success wasn't really that great, it was only 2%, but it was still significant enough that it needed an explanation. Although one of the first potential explanations did involve dark matter, and as a matter of fact that's the explanation that most scientists kind of decided to go with. But by 2016, some scientists started to think that maybe it wasn't dark matter and a better explanation could be used here for one important reason. When some of the scientists analyzed the close-ups of those gamma ray emissions, they realized a lot of these gamma ray emissions, excess gamma ray emissions, were not really that smooth. They were more or less clumpy and seemed to have been distributed in a way that suggested these tiny objects in various locations across the central region with extremely energetic objects in the middle. And the most obvious explanation for the paper back then was basically that we're looking at hundreds and maybe even thousands of different pulsars, very powerful pulsars, that were producing a lot of gamma ray energy. So much as a matter of fact that, well, it would probably need its own explanation for why they were producing so much. But assuming that there are like a lot of them everywhere, specifically all located in the central region itself, it could potentially explain what we're observing here. But generally, because this region is so crowded and there are so many things going on, this was still not really a conclusive explanation because something else could have been happening here, something else that the scientists just don't really understand. And then there were obviously some other theories proposing that maybe this was just excessive energy from the black hole in the middle, maybe something else going on with the accretion disk and so on. So there were definitely a lot of ideas, but the best two explanations were still either a lot of pulsars or the dark matter, specifically dark matter made out of Hello wonderful person, this is Anton, and today we're going to be talking about dinosaurs. But more specifically, we're actually going to discuss the idea of their demise, the extinction of dinosaurs, and some of the recent studies that discovered, well, that it really happened because of an asteroid, a collision that happened about 66 million years ago. But I also wanted to discuss some of the recent research that established everything about this particular event, including what may have happened to various locations on Earth when the collision occurred, because there has been some really groundbreaking research in regards to dinosaurs vanishing from planet Earth. But first of all, why do we even question the idea of the demise of dinosaurs from an asteroid collision? Well, up until early 90s, the scientists thought that the dinosaurs disappeared because of a major volcanic eruption that happened in the same region where we currently have India. It's this huge purple spot that you see right here. This whole spot used to be a very large volcanic shield. This is the region known as the Deccan Traps, and this actually occurred around 66 million years ago as well. And because we have a lot of evidence that volcanoes can easily change the climate of the planet really suddenly, a huge volcano like that would definitely change the climate of the planet quite dramatically. We have a really good example of a volcano that erupted in the Philippines a few decades ago that lowered the temperature of the planet by about half a degree for at least a year. But in the 90s, the scientists made a revolutionary discovery, an asteroid crater that was really huge, located on the Yucatan Peninsula in Mexico, that was created around the same time when the dinosaurs perished. At the same time, the discoveries of the iridium layer around the planet, which in this image is this relatively thick layer you see right here, has been discovered in various places around the planet and would only be really deposited by something coming from the outer space, in this case an asteroid. And so in the 90s, the scientists were pretty convinced that it was actually an asteroid and not the volcanoes. But this didn't really stop some other scientists from arguing for decades, and at the same time, there was still quite a lot of evidence suggesting that maybe dinosaurs actually started perishing even before the asteroid hit the planet. But that's of course until some of the recent discoveries and some of the recent studies. The most recent study was investigating this crater right here and was actually able to collect the deposits that you can see right here that were extracted from within the crater itself, really deep in the ground. And by looking at these deposits right in the crater, they found once again the signs of iridium, and here it was actually really high concentrations of iridium covered by a lot of different sediment, and specifically a mixture of ash and ocean sediment that essentially was deposited in this location for approximately a few decades afterwards. And this of course sort of makes sense because when an asteroid strikes a planet, and this is based on simulations you can find in the description below, this one specifically was created by Gareth Collins from Imperial College London, you can sort of see how the explosion returns a lot of the deposits into the original location, and eventually as all of this settles, this will obviously create very thick layers of both impact and ocean sediments, which essentially created this really thick layer that the scientists discovered in their samples. And because of this very thin layer of iridium in there, this allowed the scientists to quite precisely establish exactly when the collision happened, but also allowed them to see how quickly all of this recovered afterwards. As a matter of fact, one of the interesting discoveries in one of the recent papers is how quickly the life recovered, or the primitive life recovered, after the collision occurred. They even found bacterial cultures present in the sediment. But even though bacterial life was doing really well, all of the other complex life, including of course the dinosaurs, seems to have perished within about a decade after the collision. Now it's not entirely clear what was the biggest sort of influence on their demise, but chances are it was either starvation, or maybe they suffocated, or possibly a bit of both. All of this dust released by the explosion and all of the sediments now circulating in the atmosphere most likely dramatically lowered the temperatures on the planet and also prevented a lot of the sunlight from getting through for at least a decade, possibly even a couple of decades, which would obviously create conditions where a lot of these large animals would suddenly have nothing to eat and would basically starve. And one really interesting discovery here was the absence of sulfur in the rocks where the crater was located, even though there was a lot of sulfur around the area on Yucatan Peninsula. This only implied that all of the sulfur must have evaporated and was suddenly added to the atmosphere. Now, if you know anything about sulfur, this is basically what causes acid rain, and is also usually the gas responsible for the dramatic cooling of the atmosphere, which would very likely lead to some sort of a global winter with a lot of really acidic rain on top of that. But the more fascinating discoveries are actually in regards to some of the local effects. So obviously such an explosion would produce a tremendous amount of damage. The tsunami here was insane, the amount of earthquakes and amount of shaking was also extreme, and a lot of the evidence is actually visible in some of the sediments we find today. So going back to that sample of sediment that I showed you before, it turns out that roughly around 425 feet or about 130 meters of sediment was literally deposited pretty much overnight. All of this was a kind of a backwash of all of this material suddenly returning back to the same location where the asteroid strike occurred. And because this is such a huge accumulation of material so quickly, it literally creates this opportunity for scientists to learn everything about that day when the dinosaurs perished. So there are definitely going to be so many new studies coming out, analyzing the sediment, discovering a lot of new things afterwards. And then there are also signs of a massive tsunami, something that is just mind-boggling and something that's almost impossible to imagine. Apparently the signs suggest that the tsunami reached as far as Chicago, Illinois. And that means that the tsunami that started right here managed to make its way all the way here across the North America, depositing a lot of sediments in the process. And although the asteroid itself was roughly around 6 miles or maybe about 9 kilometers across, it managed to create a crater that was at least 18 miles or 27 kilometers deep. At the same time, releasing about 25 trillion tons of material into the atmosphere almost instantly, which is about 10,000 times more material than the most powerful volcano of the past few centuries, the volcano known as Krakatoa. And that volcano was able to lower the temperature of planet Earth by at least 1 degree for about 5 years or so, which also very likely created a really large explosion, although maybe not as large as you see here, possibly a little bit smaller, which set fire to everything within thousands and thousands of kilometers, with some of the debris even making its way all the way to Mars, where we can probably even find some of these rocks there today, just in the same way that we find Martian rocks here on planet Earth. There are even suggestions that some of these rocks may have made their way to objects like Titan, with some rocks possibly even containing bacterial life on the inside, and if they made their way to Titan, there is actually a chance some of this bacterial life could have survived and possibly even evolved to thrive over time. This was of course 65 million years ago, so we can't really know this for sure, but chances are still there, especially because one of the recent experiments determined that bacteria can definitely survive outer space for up to about 3 years. And following all of this, following the explosion, the tsunami, the sudden decrease in temperature, that's when possibly a lot of photosynthetic life started to perish as well. And without photosynthetic life, the carbon cycle collapses and larger organisms also perish. And this is when about 99.99% of everything on the planet started to die out, which lasted for a couple of decades. And so the fact that the collision happened and that it had a dramatic effect on the planet is now almost certainly a fact. But how do we know that the dinosaurs perished though? Because there is actually something known as the 3-meter problem. It refers to this idea that about 3 meters of deposits right before the impact seem to actually lack dinosaur remains. And so for many years scientists have been struggling to find clues or proof that the dinosaurs indeed were still around when the asteroid strike occurred. And well, looks like we might have some clues coming from the location known as Hell Creek, a really famous place in the US